Hello, everyone, and welcome to another video live stream with the Malvik Security and Hack the Box Ottawa meetup. Obviously, this is not a meetup today, but really happy that you guys are able to join us. We know this is not typical time that we do those live streams, but really happy to be able to start doing it and then do the second part of the hardware hacking, right? So I think it's going to be very interesting. If you haven't seen what it is, I'll just give you a brief overview of what I'm doing right now, or at least I'm doing with Malvik Security. Is a lot of people are wondering how to be able to get into a specific topic, specifically in cybersecurity. And then we talk about, let's say, hacking, hardware hacking, or like anything else that have to do with cybersecurity and how to be able to get into a job like that, right? So what I'm doing right now is basically I am going through the same process that I'd be doing if I was trying to hit a different market or something like that. And I'm learning about hardware hacking, right? So I went in online, I took a look at a couple of videos and so on, and I'll give you a little bit more of a rundown of what it is very soon. But it's just to say that I've done my research, and now I'm trying to move ahead and purchase a couple parts and so on, right? So all those parts are going to be useful throughout the whole process of me learning how to actually do things. But at the same time, what's important to do is to also surround yourself with people that has knowledge, that has capacity to be able to go like much further than this, and give you some of the heads up about like certain things you could do with different technologies and so on. And let's say for a multimeter, I'm not super well versed into multimeters or even like soldering or something like that. I've done a couple of moddings in the past, but not exactly up to the same challenge of what hardware hacking is actually representing. So with that being said, I just wanted to introduce you somebody that you haven't seen yet. You have heard me talking about it, but you haven't seen yet. And it's Four-Way Handshake, which has a degree in electronic. No, sorry, not electronic. I just made that mistake again. I was talking with you, but I made that mistake earlier. In electric engineering. There we go. I got it. So with that being said, there he is. You're on mute. No, you're not on mute. So Four-Way Handshake, really happy to have you over here. I hope
it's good to
you're
be
doing
here.
well and you didn't laugh too much. Me doing twice the same mistake again.
Oh, thanks for all the intros. Yeah, that was pretty good. Yeah, I'm really stoked to be here. JF kind of gave me a little bit of a teaser last night about what he's doing, so I'm really excited to see what he ordered and how we're going to proceed with this hardware hacking stuff. It's going to be a lot of fun.
Yeah. Obviously, to me, this is super exciting. This is something that I never really did in the past. I always have some sort of like an interest into it, but never know where to start. And like I said, lately I've been seeing a guy called Matt Brown, right? Talking about it and having some beginner guides and having some stuff like this. I looked on YouTube again. There was even more videos about other people doing it. And I'm like, oh gosh, that could be very interesting to give it a try and have you around as well. I think is going to be very good. So I guess at this point I should probably remove the cap of my camera on top, making sure it's turned on too, because otherwise we're going to have a surprise. And yeah, all I'd like to show you to start with is what I've seen, right? So a little rundown of what I've watched online. Let me just put my this one it is, and then
for anyone that missed the first section of this hardware hacking thing, we're doing something very different from our usual Ottawa meetup sessions. So this is, we have no guarantee of success here. We're doing it live. We're learning together. I have a little bit of background in this, but never from the hacking perspective. So, I know my hardware, but not how to break in. So this is going to be a little interesting, and, it might not work out. So we're going to do it together.
Yeah. And Four-Way Handshake, you probably don't know, but we have Jake in the chat right now talking.
Oh, hey, Jake.
Yeah.
I saw you at the Sands Challenge.
Yeah, that's right. Jake, you didn't see Four-Way Handshake before, but he was in the chat on Discord, and he was talking with us. So you get a chance now to put a face directly to an actual name, and we can contribute and have fun together at that point. So so doing really good. How about you, Four-Way? How are you doing lately?
I'm doing good. Yeah. Been getting my hands pretty dirty with some web development stuff lately, but I'm really eager to get back into some hardware things.
Yeah, that's gonna be good. And at one point, there's a project that you're working on. Are you able to say something you want to present, or you want to keep it for yourself for now?
I'll keep it to myself for now. The last really deep hardware project that I did was I made a nice little high temperature thermometer on a board, and it was all just kind of parts that I had lying around. So it was a full custom build, and yeah, it's like a candy thermometer.
Yeah, that's good.
And it
That's
runs
good.
off USB. And
Yeah,
what's
but I think
interesting about this one is that it also has a serial interface if I ever needed to flash new firmware to it. So that's going to be a little related.
yeah, that's good. And how are you doing, Jake? Let us know in the chat, and then we can keep talking with you. So, really happy to see you. You've been pretty good so far, like keeping up with us and coming back and so on. It's really good to see people coming back all the time. So right now we have about 11 people watching. So what's interesting with it, again, this is not our typical time that we actually stream. So having 11 right now, and then probably over the course of the stream, we may have even more people. So it's going to be very interesting to see that. All right. So yeah, so good. So what I'm going to go is like a really quick rundown of what we've done in, let's say, part one that happened, I think was on the 27th of December, something like that. I think that's when I started talking about it, is basically right now talking about Matt Brown, right? He's a guy that, I mean, like when I started subscribing to him, like maybe 2 weeks ago, he was about 100,000 subscribers, and now he's 125. So he's growing up super fast. Okay. Part of the things here we see here, there's like parts that he has over there. So highly recommend you, if you decide to go there, to click on his links. All it's going to do is basically put a cookie. So whenever you buy stuff, it's going to be a kickback to him, right? Then after that, we click here on the brownsecurity.com website, which we are going to be brought to directly his blog. Then after that, we have devices that he's going to be talking about. Obviously, I don't exactly have the same router, but that's going to be something to bring up very soon. Then he talks about the basic toolkits, and then even like a digital multimeter over here. Then after that, a USB to 3.3 volts UART cable with the jump wire. So that's the one we're going to go with mainly because this is the one we have. I also bought an extra device to check it out.
Yeah.
A soldering iron. That's something I'm going to show you here. Wire strippers. And then happy hacking. There we go. Okay. So here, here, I think that was the, yeah. Okay. I just had the name of the device directly over there. Okay. So with this, what's going on? Oh, that's right. My stuff are a little bit different. So am I able to keep you on stage and just have my top down? Are you still hearing me? Are you able to talk four-way right now?
I'm still here.
Okay, good, perfect. I just want to make sure because right now you're not on screen, but I just want to make sure that you're still on stage and able to talk. Okay, that's perfect.
Yeah, for sure.
All right, so what I'm going to do is, because I'm running between two different things or two different devices, since I have my top-down camera, I'm going to be able to show you the top-down camera very soon and have a picture-in-picture in there, so I can show you a couple things. I might have to get this a little bit bigger, so we'll see how it goes. But let me know four-way if there's any issues with this, or it's too small or something like this. Okay.
Yeah, for sure.
So
now I just want to jump in right away, and as you were showing us those parts online, I wanted to say that like, this space is a little expensive to break into, or at least people would have you think that. But in reality, you can buy the cheap tools, you can buy the cheap multimeter, the cheap snips, a cheapo soldering iron, and it's still going to get the job done. You don't need to blow the budget preparing for a hack like this.
Very true, very true, and that's something that I think would be good as well to bring up into a blog as well from us as we're moving along, and then have proper videos, like probably me have proper videos about what's going on. So that's probably a good topic to have part of that as malviksecurity.com courses. And I was thinking about putting it on Udemy maybe at one point to kind of bring awareness about that and then go even further. Either way, this is up in the talk. We don't know yet. We'll see what's going to be happening. But to start with, I have the first device that I just showed up, right? So this is basically a TP-Link that I have right over here. Let's say picture in picture. There we go. Was that too much? Picture in picture. Yeah, that's a little bit in the corner, but that's not too bad. Or maybe I can just turn it off for now, and then we'll see how it goes. All right, so I got my mouse. Let's move it out a little bit on the side. So I got a TP-Link. You guys don't know me, but as soon as I receive something, I need to open it up. So I have a hard time like resisting the urge of not playing with it. So TP-Link, super easy, super good. $20 Canadian, right? So, I mean, I showed you before other devices that we have. So obviously they may not be as easy to be able to play with, but you can see over there that I have basically right now like an old D-Link router. And then this one, it's also a D-Link router, but with Wi-Fi. This one's a lot more, a lot better. I'm not going to reuse
on the higher end of the consumer range for sure.
yeah, exactly. A lot more stuff going on over here because you can take a look at that, right? This one does not have Wi-Fi N, right? So it does not have that. This one has no Wi-Fi whatsoever. Okay, so we can know like, oh, it's even like I think 20 years old if it's not 25 years old. So super, super old. This one I bought it. I was in Cold Lake during an assignment with the military, and I think it was like $300, and I think it was around 2014, 2018. 2014, 2015 when I bought it. So it's still old. But now let's take a look at this guy. It's gonna be funny, or not.
TP-Link, the mark of quality.
yeah. So now let's take a look at what's going on over here, right? So I mean, I did not remove the antennas just yet, but you can see from the look of it. Let me have that's not too bad. Maybe like this. Let me see. Sorry, I'm trying to find a good angle so I can show it up to you guys. All right, so we can see here we have a bunch of different things, and what we are going to be interested, according to Matt Brown's like post or something like that he had, it's like basically this chip, which should hold the firmware, and that's something we're going to have to test around there. And then here we have also, I don't know, is it going to be good? Yeah. Over here we have the voltage, which is the first one, ground, transmit and receive probe. So not probe, but connectors there. So those little holes there, that's something we're going to be able to put probes in there and then have communication directly to our computer afterwards, right? So $20 Canadian. So if you're looking for something that's going to be super easy to start with, perfect. If you don't have the money, just go to e-waste bin, right? It could be at maybe at a store, or it could be like directly at how do you call that again? Not the dumpster, the
junkyard.
The junkyard. There we go. Thank you.
Or like a recycling center. You know,
yeah.
Sometimes it's at your fire department or something like that.
Exactly. So and those parts would be free at that point. So okay, good. So that was my first hardware hacking. Oh, my stuff are falling down now. All right, so that was the first one.
Now, JF, you teased last night all these parts that you got. You got to show me what you got. What's in your kit today?
Yeah. I'm going there. So the first one was $20. I just told you about. Okay, so this is the second one, and if we bring up to do I have? Yeah, I have it here. Can I bring it up for a second? So here you can see that this is basically the same device I just bought. Okay. Obviously there's a sticker on top of it, but that's the same thing. So if I take it out, I got this guy over here, $30 Canadian. So now we're at $50. Okay. Our goal is to be as much as possible around the $200. Obviously I overspent, but I've got to take it into account. I just want to test a couple of things, so you're going to see exactly what I'm talking about. Very easy, or at least to my knowledge, seems to be very easy multimeter. Is there anything special about this that you'd like to talk?
You know, I love that it's digital. I got to say, it is so much easier using a digital multimeter than an analog one with, often enough, even with a cheap multimeter, like a bare bones cheap, you have features like a hold function where it'll check the maximum voltage or resistance that it's experienced over a time frame. And something as simple as a backlight is a really nice thing to have. Also, if you're playing around with circuit boards, a really great thing is a lot of the time there's like a short circuit checking mode. It'll just have a little diode symbol on the under the resistance section there. And if you touch the leads together, you can get the thing to beep. Yeah. And it's really great to have a little bit of audio feedback. And
hear this.
Like I said, you know,
I hear this. I don't know if we're going to hear it through the microphone, but hear this.
Yeah, there we go. Yeah, we got it.
There we go. Yep.
And it's nice to have a bit of audio feedback, right? As you're playing around with the board.
Yeah, Jake is saying without it, no one will be able to repair any device.
Mm-hmm.
I mean,
absolutely essential.
Yeah, maybe they could, but it's going to be a lot harder to be able to achieve this for sure. So, yeah, so that's what it is. There is a good amount of features that I think you mentioned over here. Here we see that I think that's the voltage. I'm not too sure what's the difference. I think it's probably
that's like DC voltage. Yeah,
that DC voltage. This one,
and that's AC.
AC. There we go. And then this one that's amp. I'm assuming.
Yeah, for current. Yeah.
Yeah, and then the ohm. Over there. So good. So that's fairly basic device. There's a little stand over here, so nothing too fancy, but might make it a little bit easier for you as you are doing your stuff and you're trying to take a look at something, and you don't have to just like take a glance, like go over or whatnot. And then get that audible part also is I think crucial, at least to me. I got my other devices that already have, and they don't make any sound. And I think it's a little bit harder because you always have to take a look at. And what I'm saying is take a look a second.
Now, the other really nice thing, even on a cheap multimeter like this, is that the way that the leads connect to it. So on that digital multimeter that you just had out, the leads plug in with a little banana connector is what they call it. Yeah. It's like a fat little plug. And that type of thing is really easy to connect to all kinds of other prototyping cables. So it'll make your job a lot easier if you have the right connectors to begin with. And yeah, like I said, you do not need to blow the budget on this. A $20, $30 multimeter is all you need.
Yeah, exactly. Good. And here, this one, I've had it for about like, I would say a good 25 years. If it's, around 25 years. And it's still working. See? Mm-hmm. So there's potential if you're brand new or you have like you're at college or something, don't have a whole lot of money, you might be able to ask your parents, like, do you have an old multimeter that you're not using at all? Might be just good enough, right? Like even this one here would have worked to be able to do a couple of things. So obviously it's nicer to be able to get some feedback out of it. So that's why like this, it's still working and you're going to be able to do the job. It's just may not be able to do the same thing as 100%, right? So that's good. All right. So the next one was basically me overspending right now because I was very interested in technology. Give me a second. Oh, it was right next to me. So it's another multimeter. Okay, so I bought this this box here. I thought it was funny. That was interesting. And yesterday I was playing a little bit with it. I was like, oh, that's weird. And I'm going to show you why. Maybe I should have kept the other one right next to me. So they called it the Astro AI. Yeah, so I don't know if it's really AI that much. It's interesting. It has a function in there that is going to be basically discovering or know exactly what you're looking for pretty much. So that's the thing. And we'll see what I'm talking about. Okay, so if I plug this in and then I turn this on, batteries are already in. So you can see here, everything is digital. I'm going to take my other multimeter again. And you're going to see exactly what I'm talking about between the two very soon. Okay.
I'm really curious about this thing. Jeff, you might have a problem, buddy.
I might have a problem. What do you mean?
A shopping problem.
Yes, I do. You're not even like it's not even a surprise. When I take a look, I like to test things out. But the biggest issue I realize is I test them out and I keep it for myself. And I realize it's not a good way of doing things. I think now I need to start testing them out and then talking about it a little bit more on YouTube, and then have you or anybody else being able to see what I'm actually doing, and then probably inform the consumer even more, right? So this guy, $20 more than this one. So we're talking about, let's say $30 for the Unity, and then $50 for the Astro AI. So when I showed you a little bit earlier with the beep, I don't know if you're going to hear it still. Are you hearing from there?
Mm-hmm.
Okay, good. So you hear as soon as it touched the two prongs, it works together right away. So if this one, I go, okay, it's a little bit, I'm not seeing super well from this angle because unfortunately it's reversed for me. Now, if I take this and I do a fairly similar thing, see? Now I press on it and it takes a while before it starts. Maybe like a second or sometimes two. So that's an issue. So now they touch. Oh, I don't have anything right now. Oh. So take a good second. So I don't know how good it's going to be. Obviously, it's super small, super handy. There's like a little, what's called a flashlight on top of it, right? That's right there. So it's kind of neat. There's a couple of interesting things. There's the auto, which is the automatic things that I guess the AI things is. So as you can see here, it's going to go through 3 different modes. And as you're testing out your stuff, it's going to be telling you exactly what it is. So I tested a battery, and then it told me 1.6 volts for AAA. I was like, okay, good. It went straight up to voltage directly, right? I tested a couple of things, and it just moved left and right. Was it really good for me? I'm not too familiar with this, so I was like, oh, I'll have to test it out even more. But I thought it was very good or very interesting to to test it out.
But you could still set it manually, right? Like say you were checking the resistance across that same battery, you could.
Yes. Okay. You can see here, if I press the auto button here,
all right,
like the button in the middle there, it goes to voltage, ohm, and then keeps going, right? I just have to press every time and then brings me there. Probably a couple of things also that's going to do something else, but that's what it is. So, hey, Zenitsu, how's it going? I hope you're having a great day, and thank you very much for showing up. Just make sure this is an interactive session that we talk about some of the hardware that I just purchased, and then I have 4-way handshake with us in the background. So you're going to see his face very soon. I'm just demonstrating those things first, and he's still talking. So if you have any questions or whatnot, just make sure you put them in the chat, and then if we're able to answer them, perfect. If not, well, we are going to take notes and then let you know back a little bit later, hopefully in the next stream or maybe online on Discord. All right, so that was it for that one. The next one was the third device. If I bring up my screen over here, okay. So the third device was basically the USB USB to UART basically cable. All right, I got it over here. If I turn it around, maybe I should take a look if there's anything. Nope, there's nothing special about me in there, so we're good. So you guys don't have to dox me or something like that. This is basically a DTEC 3 feet, 3.3 volts. You can probably see it over here, right? So it's the same description pretty much about what you can see, this side there, right there on that screen. That's going to be there. Very simple. It's kind of straight through, but I think you have some comments about that.
I do. I visibly cringed when you brought this out, and I just need everyone listening to this to know that it is possibly quite harmful to your laptop to use a device like this. If you're not quite sure about the circuit that you're hooking your laptop up to, straight through your USB port, you could damage your computer. So there's a couple of different ways to make a serial connection, and one of them is using something like this, where you're directly using your USB, your universal serial bus, as a serial connector. But a little bit more normal of a way to do it these days is to use like a thing that plugs into your USB that acts as an intermediate device. And what's really important about that is that there's, within that device that you plug in, it has all the protective stuff that you need to keep your laptop safe from this kind of, I want to say, untrusted circuit. Because you never know what's in the chassis of what you're hooking up to. And sometimes you know, it can be as simple as you accidentally knock one of the wires that you're using to hook up to something, and all of a sudden it shorts out your USB port. Boom, you just fried your USB port. And that's never fun. Repairing a laptop isn't cheap. It's definitely a lot cheaper to go with this little guy that JF just pulled out. Can we see that a little closer?
This cable over here, or are you talking about the new one?
You bet. So we see 4 wires coming off of this little USB device that you just pulled out. No. So yeah,
this one.
We have the cable, but these 2 things are kind of this. They do the same job, but this acts as an intermediary. So the one in the little device in JF's hand, it'll give you that extra protection to keep your laptop safe when you're doing this kind of job.
Yeah. So if I can bring it up close enough, hopefully it's going to work out. You can see on that right over here, there is pins, right? So jumper pins where you can take it off and put it somewhere else. So right now, the way it's set up to 3 volts, right? So it should not go over 3 volts and should have the protective resistance in there to be able to stop if it goes beyond that and basically burn it. So if you guys are familiar to what we've done on, I think it was on the 28th of January, sorry, not January. We're not even there yet. December. We covered the SANS hacking challenge. I can remember exactly what it is, or the holiday hack challenge. And there was part of it that we had to switch from 5 volts to 3 volts, right? Because we were burning basically the chip at that point. Obviously, it's just a game, so we didn't burn that much, but it was just a good representation of what 4Way's actually talking about. As we can see here, if we want to, we plug this into the device. I can remove this because it's basically a jumper between the transmit and receive. I'm assuming, correct me if I'm wrong, it's basically to make the connection between the two. So if you plug into your computer, it's basically talking to itself.
Let's see.
Well, the jumper.
Can you show me what's in your hand?
The jumper here, this one, right?
Okay.
It was basically jumping between it was basically over top of the transmit and receive. So I'm assuming it's just talking to itself at that point if the jumper stays there.
Oh, yeah, that's exactly it. Yeah, you nailed it, man.
Good. Perfect. And then this cable here, we can put it there. And then after that, we just have to basically go with the naming convention that they follow. Like, it's pretty simple over there. So we have, again, to your side over there, we have the voltage, the ground, transmit, receive, then the RTS and CTS, right? Does it mean anything specific to you when I say CTS and RTS 4-way?
Yeah. And actually, for anyone that was there for that holiday hack challenge, we encountered that very, very briefly. So RTS and CTS are pins used in flow control in serial communication. So those stand for request to send and clear to send. So like when you want to send, I don't want to say packet, but it's more like a data frame over a serial communication. You'll raise the voltage on the request to send pin. And then if the other end of the communication is using that kind of flow control, it will say, okay, yeah, this laptop is trying to send to me. And then it will respond by raising the voltage on its clear to send pin. So by using those 2 pins, it can kind of, it's like a synchronize and acknowledge in IP, if you're used to that.
Yeah, exactly. So obviously, at the same time, I can probably answer Jake's question, right? About if we have a project board. Yes, we do. I just presented it a little bit earlier. This is the TP-Link that I bought for about $20. So the one, well, not necessarily the one, but the brand is being talked right now at the U.S. government. I can't remember exactly, government, whatever organization, right? And they're taking a look at potentially banning TP-Link completely, right? So I thought it was also a good example to just, like, for me, buy a $20 one, because they are getting more and more market share right now, these guys, because they're so cheap, but there's probably a reason why, right? So this is what I want to discover in this case. I could go online. I could just take a look at videos and understand exactly what it is, which little shocker. I already did. But at the same time, I'm like, it's not the same thing as you doing it yourself and understanding exactly what you can do and then maneuvering a little bit around instead of just like getting information from someone, right? So this is the validity that I want to build up by myself. And also being able to say, look, I hacked a couple of devices myself and I know what I'm talking about because I've done it. Instead of just watching videos and just kind of pretending I've done it in the past. You want to say something?
And for a thing like this, you know, cheap is good, right? Cheap is our friend because cheap means that it's widely available, which often means that it's widely documented, and it costs a lot less to start up a project like this. And from the production side, it also means that, hey, maybe they skimped a little on security, which is going to make our job a little more rewarding, hopefully.
Yeah. And the other thing too, as you were actually talking, I was telling myself, I'm like, look, is it possible that there's not a whole lot of people in the world that has a ton of money that will spend, I don't know, $1,000 onto a really good router to be able to make it worth it for them? Technology is advancing so much. A lot of people are going to be looking for the cheapest one to be able to satisfy their need because obviously it will satisfy their need. But will it? At the end, it depends. It depends how you see actually things up, because if you get compromised, that's when you get compromised that things are going south at that point. But for now, this is what we have, and you're completely right on this. You don't need to start with like something that's going to be super expensive for a project at this point. So I hope that answered your question, Jake. Are you ready for the next one? Let me bring the next one. Okay, so number four, if I bring this here, number 4, we're talking about a soldering iron. Okay, so I have another one. That one, you haven't seen it yet. This is something I bought when I was doing my modding. And I was 15 years old. Again, another 25 years old device that I've gotten when I was a kid, and I was doing modding with PlayStations 1, if you can remember. That's a long time ago. Yeah. PlayStation 1, started PlayStation 2, then I stopped. At that point, I made a couple of mistakes. I burned out a couple of PlayStations, unfortunately. I don't know if they were too old or I made a mistake. It's possible, but at the same time, I didn't have the same gear to be able to accomplish the same desired results. Obviously, I didn't have the same amount of money, but I took $100 and I spent that money on the device I'm about to show.
Yeah, there's nothing wrong with an old soldering iron. As long as you take care of them, they will last a lifetime.
So you're going to be surprised, but this is the original box. I'm quite sure. Yeah, that's still the original box. It doesn't say much on it, but you can see here, right? It shows like on the screen that you see right now over there that you can have soldering iron. You can bring it to, let's say, if you're doing CTFs for that specific things. But in our case, obviously, I'm not doing that right now. So I'm just going to concentrate myself into what I currently have. I would say that I looked online. There's probably $50, $100 you can spend on to be able to get something similar to this. Will it be 100% the same thing? That's probably something I need to do a little bit more digging. But now I open this up, and then we are going to be welcome with my old device over here, right? So let me take this out real quick. Still working. It's insane. Like I've done so, I still have that's not even cleanly that much. You can see there's still like lead. I don't know if it's going to show up over there, but like over here, there is like little remnants that are still there. I did not clean it up completely. So
yeah, a little safety moment, everyone who's listening. As soon as you start soldering, right as you're getting your soldering iron out, make sure you got your nitrile gloves on, like some latex gloves or whatever. And because this stuff it soaks through your skin, and lead is for life.
Yeah. So I got this here, my iron that's going to be plugged in up front, right? I'm going to put it back there. And then that's the little thing here. I got something that I bought a while ago, and I was like, I'm not even sure if it's working fine. Is to remove, like, if you make mistakes or something like that, you're going to be able to kind of pump it up, and then as soon as you put your iron on top of it, you're going to be able to suck in the lead, right? So
yeah, solder sucker.
Yeah. There's that. I got lead over here. Again, this one, I think I bought it. I was around like. Yeah, about 24 years ago, maybe 23 years ago, and I still have some, right? So depends if you use it often. Obviously, it's not super expensive, but that's something that could be very good, very useful for you, right? So that's my little device over here. Other than this, is there any other tip that you would like to give others other than the nitrile glove and iron?
I mean, don't go too cheap on a soldering iron. Weller is a really good brand, and like you can definitely pick up a nice Weller soldering iron for $50. What I would stay away from though is a bare bones cheap battery powered soldering iron. That's going to be a little too weak to be able to use for the type of job that we're doing.
So are you thinking that this one is not going to be that good?
I wouldn't advise that one. No, I'm a big fan of one that plugs in and one that is very clear about when it's on. Bonus points if you can adjust the power going to it, but like I can see on yours. But frankly, my daily driver soldering iron has no power adjustment. It just has a really nice tip. And when you buy a good brand like Weller, it is built with good materials. So you keep it clean and it's going to last you for life.
It's been 25 years. I mean, all I can tell you is obviously I've used it a little bit since then. Do I still have it here? I don't know where I put it, but you know, the other, like the old multimeter, I was able to get the two cables, like the prong and the cable, to go back together. Nice. I welded. The other thing too is you can see here I have a couple of resistors, right, that I bought a little while ago, and
those are capacitors, yeah.
Sorry, yes, thank you very much for correction. So those capacitors, and I was able to fix my screen. I had a screen that was like dead, wouldn't work at all. I just opened it up and realized that there was a little bulge on top of them. And what I did is I removed them and I put them back. And that screen is still good right now. And it's about 20 years old, right? So even though I thought it was bad and I was just going to throw it in the garbage because it wouldn't turn on anymore, I mean, it was still like I revived it with just like, I think it's like a couple cents per.
Those are 10 cents each.
Yeah, exactly. And I have another one because I had two different capacitors I needed to change. And then I changed this one too. And then bang, everything works. I'm like, oh my God. I mean, I was about to just like spend money onto buying new monitors to be able to use them. And then eventually never needed them. So, which is good at that point. All right, let's put that back into the box. Because that's the soldering iron that I have. I'm going to be able to go. So technically speaking, if we're going with budget right now, do you think that $100 would be fair in general for a decent soldering station? Not exactly maybe as this one, because obviously that's like 25 years ago I bought it. So the
totally
have changed. But do you think $100 is still valid?
That would be extra. Yeah, for sure.
Okay, good. That's perfect. So happy to hear that I bought something that's not too bad. All right, so wire strippers. I'm not too sure if that's going to be that like necessary, but yeah. So I mean, like this one, I already had it, so it's not going to be something that I'm going to be saying that I bought myself. But I think maybe $10-$20. That's something you're going to be able to spend on, and you're going to be able to use them. If we go again with what Matt Brown was saying onto his what's it called again, is blog post. Okay. So
go ahead and get a cheap wire stripper. There's nothing wrong with the cheap one. But don't go without one. If you're one of those people that like strips wire with a knife or something, you're going to hurt yourself pretty badly one of these days. So just go get yourself a little $10 wire stripper. It's worth it. And you'll speed up your work.
There's other ones like this one too.
Yeah.
I mean, that's not necessarily a stripper, but I've been using it a little bit before, specifically because I'm using it for Cat5 when I have to put the, you're going to see exactly what I'm talking about. For those that are not sure what Cat5 is, let's take a look. I got a little N over here. So whenever you want to put it on and you want to make sure that it grips on, because obviously if I just give you, hold on, I'm going to take this one out. So are you going to be able to see it? There we go.
Yeah,
okay,
yeah.
So you see those little pins? Maybe you're not going to see them well enough, but there's little pins here that normally you enter into the jack, into the port. And the thing is, those ones are going to crimp directly onto the cable. So that's why you're not going to be able to pull afterwards, right? So all you got to do is you put it in there, and then that's going to be working the other side here. Okay, so that's the purpose of this tool. But I've been using that little blade over here, not necessarily this blade, because it's like there's two on either side. So it's just easy enough to just like put it like this and just turn the cable and get it done. So obviously, if you have a wire stripper, that might be even better than a tool like this. But obviously, if you can, you just use whatever you have at hand. You may not even need, well, if you go with what Four Ways saying, you should have one if you can afford it. But if you cannot afford it at all because you have to go and make sacrifices on some other stuff, this one, you can probably put it on the side for now, but buy it as soon as you can to be able to avoid the headache that Four Way was talking about.
So there's a big difference in cost between what JF has in his left hand and his right hand. So the crimper stripper, that could be like $100, but the little electronics wire stripper that he had out first, yeah, $10 will do it, and it's gonna be fine.
So that's the one here.
Yeah,
Sorry,
exactly.
I had to bring them back alive. Good. So that should be. Hold on. Sorry, I had something in my throat. Okay. All right. So now we have this. This is the end, basically, of what he's been talking about into his things, right? So if we come and take a look here, we're going to see that he has a stripper, and well, not a stripper, but he has a wire stripper. Makes more sense at that point when you think about it. That's going to be there. So that's going to be helpful for this. However, I kind of feel that there's some other stuff that might be missing out a little bit. Oh, it seems that it did not go. There we go. Thank you. I kind of had both of them at the same time. I guess I pressed on the button twice, so it kind of stopped moving to the other image. Yeah, so I think there is stuff that are missing, part of potentially the beginner stuff up to a point, right? So obviously, if you're able to extract information using the UART, it's going to be great. But you may eventually need to do a little bit more than this, and that's why I bought the other devices I has not talked from his blog post. Okay, so I got this little things here. Let's move this plastic there. Okay, so this is the other thing I'm referring to over here, right? So that's basically the chip. Maybe I can't. Sorry, I gotta bring up my stuff, and I need to change the camera.
Before we move on from the wire stripper, I just wanted to add a really great thing if you're doing projects like this is to just spend the extra $1 or $2 and buy some good hookup wire. So this is like 20 or 22 gauge wire, solid wire, not stranded. That is really easy to solder to, and in a pinch we could get 4 of those little wires and just poke it through the board and solder it directly on, right on that UART port that JF was pointing at before, and it's super cheap. So just get some. It'll save yourself a lot of fiddling around. So that's really thick. That's more like household wiring, it looks like, or maybe just the zoom is a little. I don't know, but yeah, 20 gauge, 22 gauge. It's pretty thin, easy to poke through holes in a board, and really, yeah, more like those.
Okay, so yes, there is a big difference in between the two, obviously. So you're probably right. I don't know what's the gauge. Does it say on this one?
Yeah, it should be printed right on the side of the wire. That's how you can tell.
Well, it's another cable that I've been using, and then just like once in a while when I needed it. So I don't know if it's written still. I don't see anything anywhere written.
Going a little too thick isn't a big deal. It just means it's going to take a little longer to solder to. When you're hooking up to a circuit board, though, there can be a problem because it means you need to hold the iron against the fragile circuit board.
Yeah, very true. So if I take this off over there, and then basically if I need to put a cable over here, you can see what you're referring to. It's going to be super big to be able to solder it there on that chip, or it could be over here, so it's going to take the whole hole, right? So it might be hard to be able to do that. However, if we can take, like Four Ways talking about, if we take a little cable like this one, like we can see the difference between in the size and between the two. I know it's probably not as representative from your angle or something like that, but believe me, whenever I take a look at it, Four Ways is completely right that a cable like this is going to be much better than the other one. But obviously, if that's the only thing you have in hand, that might be the only thing you're going to be able to pull for now, right? So trying to see how you can maneuver around and adapt and overcome.
That's true. You know, it's better to use what you have on hand than to not be able to start the project at all. Definitely.
Yeah, because you may never start it, like you're saying.
Yeah.
Very, very good point. All right, let me move this one a little bit to the side because I keep bringing it back, so at least it's not going to be too far. All right, so I guess I can bring it back. There we go. It's coming. So that chip here I was talking about, okay, that's going to be one of those things that's going to be very interesting for us because this one holds the firmware. One of the comments that Matt Brown is saying, again, I'm not going to say that he holds all the knowledge in there, and I'd like to have your opinion as well, Forwey, on the matter. He's saying that if you start plugging or trying to use like cables to like prongs or something like that are going to go and then it each like little legs there, and then you start like putting a little bit of voltage there, you may not be able to extract it correctly. The reason behind that is like as soon as you start giving voltage there to that chip, it might give voltage elsewhere and then may corrupt basically what you're trying to extract from the exact chip over here. It may work.
Yeah.
Some other people are saying that there's another thing you could do to be able to avoid this. But in this case, I mean, like for me, I'm not too sure 100%. I do believe what he's saying is right. There's maybe other way, and that's something we can probably take a look later on. What are your thoughts on that, Forwey? Do you think
I think he's absolutely correct, and in a couple of different ways too. So there's a really high potential for accidentally shorting out an adjacent circuit, right? Because the leads are really close together on a circuit board like this. Yeah. But also you've got the potential of just accidentally sending off a bit of a stray voltage if we're using if we're sending a signal through the wire. So if there's a neighboring lead on the circuit board that's a little too large or something, you might pick up a little bit of interference on there. And if we're dealing with the like millivolt or microvolt range, you're going to be able to see that from elsewhere in the circuit. So in terms of direct short circuits where you're actually accidentally touching two different electrodes at the same time, and also like crosstalk between two wires going through the air, it's a problem. So having a good, reliable way to hook yourself into the circuit is going to be essential for a task like this. Yeah. So sorry, I lost track on the chat. I see Jake was talking about RJ45. So yes, that was the connector I had a little bit earlier and the crimper I was using to be able to do RJ45. I had a little bit on top of that crimper, RJ11 as well. That's old. Is there anybody remember what RJ11 do without Googling? Well, that's a phone. Yeah.
Oh, you're giving the answer.
Oh, sorry, man. Sorry.
You're giving the answer. I was
like, damn.
Trying to interact with them as not exactly a course, but I mean, it's fun to be able to talk about this. You guys got a freebie this time before we help you out.
Oh, sorry, guys. No, for me, it's just a trip down memory lane. Yeah.
Yeah. I got a couple cable, maybe not here, but I got a couple cable that are with RJ11 still. The only reason why I'm keeping them is just in case I need them, but I might start throwing them out eventually because who use phones anymore? All right, so I'm going to move that again a little bit to the side once more and come back to over here. So once we take out that chip I just showed you, the goal would be to be able to put it into little devices like this, right? So you're going to be able to see that we have pins. So we just put the chip in. Maybe there is something else that we can do to be able to do something else with it. That's something I'm going to have to check out, right? But it seems that has the correct pin. And I would need to find out if it's going to be clamping. Oh, I need to press on them. Okay, good. So I did not realize it. I press on them. There's like little, what's called springs on that side there. And then as I'm pressing on them, they are moving out. Once they move out, I put the chip in and then I just release it. And then the chip should be clamped directly to this board. Once this board is there, and again, this is me just going out of seeing videos on YouTube and not knowing how it works 100%. But there's apparently a software that comes along with this that I could install into my my machine, and it will tell me exactly where I need to install it. Most of the time, what I've seen is it needs to be installed, I think it's towards the bottom, which is like this, technically. I mean, like if I want to put it this way. You guys, that's like that. Sorry. You guys are reversed than me. So I put it like that. And as I'm taking this down, it's going to clamp on it, right? So if I put it back up, it's like free. And then if I bring it down, it's going to be clamping directly on all the pins. And now it's holding up. Okay. Then obviously we have a USB that's going to be plugged onto my computer. Again, this is a computer that is super old. It does not need to be like very recent or something like that. This is the computer I will be using, right? So this is a ThinkPad, has Intel in it. If it wants to open up, and you're going to be able to see it's like super old laptop. The screen is not even 1080p, so it doesn't matter to me. I got, not on that side. Yeah, I got a couple here. So I got a couple of USB 2 over here. I got VGA just to show you how how old it is. And then on the other side, I got still the CD drive over there that can be opening up, and then another USB port. So very, very simple. I put an SSD in there, so it's easy enough to be able to open it up and put an SSD instead of the HD that was there. So it's going to make it a lot faster than anything else in this case. So that's how I was able to revive basically a computer that most people would throw to waste normally, right? So again, we're reusing what people don't want to use if we can, especially that we might get them for free. And then after that, we can move along. Okay, good. Sorry, I sidetracked it a little bit. So I see Cosmic Red M, best viewer on stream. Okay, we need to. That's not something that should be there. That was on Twitch. Can I get my thing back over here? No, I cannot do anything with that. So either way, that's something I'm gonna have to fix eventually on Twitch. It does not matter. I'll take care of that. So good. So we have all other things that we that could be very interesting. I think that's something like this you were telling me about. Not necessarily this, but I think you were talking about that a little bit earlier.
Let's see it.
About these.
Yeah, it's header. So this is pretty standard DIP header. So it's what that means is like it's a certain size and it's really easy to poke through exactly those little holes that he's holding.
Yeah.
And solder it right onto the board. You see this all the time if you're doing prototyping stuff or playing with hobby kits or anything like that, because it's really easy to work at this scale. It's much larger than the stuff we're going to see on the circuit board that we're playing with. But for this prototyping type stuff, it's easy to solder with.
Yeah, good. And you were saying also at one point, because obviously all the devices needs to be powered on eventually. Mm-hmm. And some devices you may not have everything you need. So I don't have one with me right now. It's somewhere else in the house, but I do have a breadboard where you can use that. But I think you were talking about as well, like if you have, let's say, those power brick over here, right?
Yeah. So yeah, having a nice reliable power supply is essential. And you know, thankfully USB is sweet in that it gives us both 5 volts and 3.3 volts, which for those people that were paying really close attention, those are exactly the TTL voltages that we use. USB provides both of those right out of the box. So every USB connector, you can hack it into a really quick and dirty 5 volt and 3.3 volt power supply.
Good. So it'd be a good way at one point if you actually need a power supply that has the correct voltage and correct everything, if you know what I mean, to be able to basically just like remove this, splice them, and then just solder them onto the little pins that we just saw about, right? These ones, and be able to put them on the breadboard if you need to, right? That's what I think you were talking about.
Oh, definitely, yeah. So I have a little desktop power supply that I think I got it for $30 or something, and it's dead simple. It has a little rotary switch on the front that you change the voltage and you just turn it on and off. But it has its own fuse inside. So if you're going to burn it out, that fuse will pop first. And yeah, a reliable power supply, like the whole circuit always starts with the power supply. So having things nailed down in a certain sequence will really help make your life easier as you're doing a job like this.
Yeah, true. And the thing is, as I'm realizing it over here, those little pins are the same, and they've been soldered
Exactly.
on this board.
Yeah.
So that's basically the exact same thing they've done. So
What they've done here is taken a really, really fine pitch, a four-sided chip,
yeah,
a surface mount chip, and turn it into a dual inline package DIP that you
nice.
can just plug directly into a breadboard. Do you have a breadboard to show us, Jeff?
No, I don't have one with me. I would
Okay,
need to
all
find
right.
it. It's somewhere in the house.
Hold up. You want to put me on camera for a sec?
Sure. 1 second. It's coming up. Let me put you up front.
All right.
There you go.
This is a really cheapo little breadboard, and this is what I'm talking about. So there's lines up and down both sides to hook up your positive voltage and your ground, and then rows and rows of places to stick those DIP pins into. So all the rows are connected together, and all the strips down the side are connected to each other. So it makes prototyping really easy. Thanks, Jeff.
Sounds good. It requires me a little bit of tinkering around to get the right stuff, but
yeah,
good. So, you're saying you have one, Jake, right? Why do you have one? Do you have one because you bought maybe a specific device or a Raspberry Pi, or you had a project in mind that you wanted to do? So let us know in there, and then we'll get back to you soon. I'm going to put that back in there in the meantime, right? Because obviously it's good to have them, but I don't want to damage them too much. They're going to be going back into the package. Some stuff I don't mind them having them around, but stuff like this that are so fragile are going to go back where they belong to. There's a USB cable that comes with it, and there's also, I'm not sure if I'm going to use it, but that's an extractor. So I'm assuming if you use a soldering device and then you decide to put it directly on top of the chip, let me see how it would work. I guess something like this, and then potentially put it out that way. Not even sure if that's working, or it's. I think it's too large. It's too large for that. That's weird. Maybe there's another way to be able to.
Wait. So you want to have one side of it over on the antenna edge, and then the other side on the edge that's furthest from the antennas, right? You want to grab the chip on the sides that there are no leads. Yeah, exactly. Yeah.
That's what it is, but it's not going to work because it's too large. So it seems that.
Oh. Okay.
Yeah, it's just too large. I can open it up that way if I wanted to, right? So it's feasible to bring it up this big, this wide. But this is the minimum I can go to. And then the chip over here is just like, I don't know if you're going to see it. It's just like, it's not going to work. It's just maybe a millimeter too big.
To be fair, if we're pulling the chip from the board, it's probably irreversible. So there's nothing wrong with just heating the board up and using a very small screwdriver to remove the chip.
Yeah, probably. Don't pull too hard because you can
never force anything. Yeah.
So you want to put the chip back, obviously, because with this you want to extract it, which is great. Mm-hmm. But once you extract it with all the tools you have, you may want to put it back so you can keep going with the UART. But in the meantime, you have basically, let's say, the firmware that you can utilize with something else. All right, let's clean this up a little bit. Gets dirty. That's my Hack the Box mat. You guys don't see it. It's right. It's just like right there. All right. Good. Put that on the side. So we talked about those cables as well. That were good. So I bought a couple cables. I think it's like $15 to be able to get like a bunch of them. I'm assuming that I may do what you're saying about some of them. I may cut them, but I know some of them, sometimes what you can do is, do I have the other thing? No, I don't have it around. But you can plug it in, and then this one you're going to be able to plug it onto the board directly because sometimes there's pins sticking out. So it's going to make it easier in this case, right? Some of the case, I'm going to put it directly on that USB UART thing that we just talked about. And then the other side, I can probably probe it directly inside the board with this. So we will see how it goes. For now, that's what it is. But it was just $20, and I was like, I may need this at one point. So you know what? I don't think it's going to hurt. And then having a breadboard as well, like you just showed us, it's probably going to be a good plus for this.
Yeah. So JF, you just pulled out some wires that are female on one end and male on the other. Super handy for a job like this, because you can use the male end to solder directly into the board. So you'll end up poking those pins up through the back of the board and soldering on the front, and then taking the female end and plugging it right onto that USB to serial converter that he had up before.
Yeah, I think that's what it is right there, right?
Yeah, exactly.
The male to female. So
yeah,
depending on how it is, I'm trying to look for my other device. Give me 1 second.
And even though these wires are all connected together, it's pretty customary to just snap off what you need. And so we only need 4 wires for this task. So you just break it right off the strip.
Correct. So now if I plug this one in, just to make the representation of what it is, what I don't want to do is basically modify this cable, because this cable, to me, it's fine. So in this case, what I can do is I can just take, let's say, this one end here, take it off. Now I have 1 cable. And then I can just put it on, for example, if I want receive, in this case, I don't know if it's receive. It's just for the sake of learning here. I put it in, right? So now that's my receive end. And then now I can either put it on the board like Four was talking about. I can cut it and then solder it directly on the board if I wanted to. So there's a couple things. But yes, very true. We can do that a couple times depending on what we actually need on this USB device.
Mm-hmm.
Good. Put that back. So that's something I should probably went over right after I introduced the soldering iron. But if I put that over here, the soldering iron, we have this, right? This is flux. So am I able to open this up? Well, I guess it doesn't matter too much. So it's like a syringe, because if I open it up, we're going to have access directly to it. So either way, there's like a little syringe that's right over here, right? And then after that, we have the rest of the package that's going to be all together. So once you assembled it, it's going to be much easier to be able to apply this. So once you use soldering iron or hot air, sorry, I'm French, so sometimes I put H's everywhere. So I was trying to pronounce it correctly. So once you put it together, you put you use the hot air right there onto the actual chip, right? This one. You are going to put the flux. So this flux over here, you put it there before actually using the your soldering iron or any other devices for soldering, and then you put that there. The reason behind that, and correct me if I'm wrong, I'm quite sure you have a little bit more experience on that four-way. It's basically, it's gonna how can we describe that? It's basically going to make sure that it's going to simplify the whole thing. It's going to be easier to unsolder, and then this, like, all the lead is not going to all stick together. It's going to stick more to the path we were originally at. Am I correct?
You know how when you're frying something up on the stove, you use a little bit of oil to keep things from sticking to the pan? That's what flux does for us. So it keeps things separated, and it acts as a heat transfer fluid. So it allows your hot air gun to actually effectively push heat onto the leads of the chip instead of onto the chip itself. So it's going to make the job of pulling the chip off the board a lot easier.
Okay. So yeah, exactly. So that's good in this case. Thank you very much for the information there.
You bet, buddy.
Yeah, so I use I bought this one. It was another $10. That's going to be very handful. Very good to be able to do that. So I think this is something that he's missing into his, unless I didn't see it, but he's missing into his blog post. Either way, it's still a good blog post to refer yourself on, but that's something I should have probably talked about. Okay, I see that Jake wrote a little something here. Oh, I forgot to put this one on. Said, I was in school and we were doing projects on it. This was before Corona. So COVID-19, probably. I haven't touched it since those days. Okay, good. And where did you get up to on your project for this? The other thing too I'm looking or reading is I like to buy things like Malvik, but I don't use. That's my problem. Oh, I mean, I'm buying them. I'm buying a lot of different things. I don't use them all. But I end up a lot of times using them later on. So a lot of things that you guys don't see right now, if I move around, a lot of what you guys don't see around specifically, like right now, my setup is there's a lot of stuff I bought that I was not using for a while. And then eventually I realized that I needed to figure out a way to utilize them. And instead of trying to buy new stuff again, I need to repurpose them. So there's a bunch of stuff here that you don't see, but they are all like either I bought them 10 years ago and then reusing them or so on, and trying to see how can I repurpose these things to be able to move forward. So I do a lot of that, but I do like to test as well. So ask me if I have a subscription on something. I may have it. Or I canceled it recently because I realized it was just too much. That's good. That's good. Like the device I'm using to be able to get back and forth, like right now over here, like between those ones, is a device I bought. When was it? I think it was in 2019 when I bought it. Yeah, I think it was in 2019 when coronavirus hit. I was thinking about joining IBM, and I wanted to do a couple of videos and stuff like that. So I was like, I have a Mac. I want to use a device that's going to help me out to be able to record and stream and stuff like that. So I bought this one, and I did not accept a job with IBM, so I spent money for nothing. All right, so we have another one. So I'm doing these ones before I get to the big piece, because the big piece is going to take a lot of space. Just going to put them back here.
What? There's something even bigger? Those are some pretty cool devices you already pulled out. So
yeah,
I'm already overjoyed.
Just wait, you might be surprised. So this one probably not necessary. Again, it was like $10. I didn't care that much on this, but they're like little prongs. Let me take one out. So I don't know how useful it's going to be. When I saw them, I was like, I'll just buy them just in case. Never know. Again, this is not super expensive. They're super tiny. So this one, like, it's maybe I should move to the other one. So this one here, it's like a 90 degrees, right? Thing. What I can do with that is basically, I need to open this one up too. Okay. It's basically, you got a alligator clip. You just put it in, right? And then if I need to plug that somewhere else, I got the alligator clip, and then I got this one. So if I need to put it directly into the board or something like that, I might be able to use something like this if the other cables like this are not working, right? There's multiple different ways for me to be able to maneuver around. And I can probably, again, I'm not sure if I made a mistake, but then again, this is me learning at the same time. Yeah, there we go. It sticks to it. So I could potentially just like put it onto a cable like this, and then be able to use this other end to put it somewhere else where this one's going to be more handy, right? So that's what I bought there.
And having a little L-shaped probe on the end of that wire there is kind of handy if you're doing something fine and fiddly, like a circuit board in a router, because it's a lot easier to precisely hit exactly the lead you're trying to touch if you're resting your hand on your table as you're doing it. So it saves you from awkwardly holding the probes of your multimeter or oscilloscope or whatever up in the air. Yeah, and that can make all the difference.
Very true. Very true. And we're going to see, I got something to be able to help up with that. But obviously, if you don't have what I have, you're going to be able to go a little bit further. So that's another type of alligator. I'm not too sure in which case I would actually use that. I don't know if you're going to see it well enough. Let me just bring the two of them close to each other. So
I mean, it's basically the same thing. Yeah.
Yeah, it's basically the same thing, but I don't know exactly what's going to be the actual difference in between the two. Is it focus correct? Or either way?
There's going to be a little less slip side to side on the blue one, and the yellow one was probably a lot cheaper. Yeah, which is fine. That's what I have in my toolkit is like your yellow guy.
Yeah, exactly. So it's good. I'm going to put it back here. I see another comment here. What is the golden thing that they had to remove electrons? I'm not too sure. Are we able to answer that question, Orway?
What was the question? I'm not seeing this.
It's on the screen right now.
The golden thing that they had to remove electrons. What? The golden thing on what? Sorry, Jake. I'm not quite sure. Was this a piece of one of the devices that he was showing us?
I'm not sure if that's one of those devices. Well, we'll wait for Jake to respond back, and then we'll get back to the chat whenever you answer this.
Yeah, for those in the chat, there is a bit of a lag for us, so we do the best we can.
Yep. You see the chat as well, isn't it? For
I actually don't. So I'm on YouTube right now and on Discord, but I'm not seeing where Jake is. So it's probably my fault.
Yeah, you're not streaming. You're not seeing it from the actual stream that we're doing right now.
No, I'm on the live stream on YouTube, but
okay, that's fine. All right, one more, then the big piece. So, I mean, the big piece is basically part of this, I would say. So that's basically a soldering mat, right? Where you can put, let's say, your board. Let me take a board. Put your board over here, right? I mean, like it says the circuit board location area. That's what it says. Let me reverse this back so it makes more sense to you. There we go. So now you have the circuit board that's going to be here. That's what it says. You can put your screws over these locations. You can put them over here as well. You have little enclosures that you can close afterwards, right? And then a bunch of different things that you can actually do and hold your devices there. One of the things that I hate about, in general, what I do is I was doing everything onto my Hack the Box mat, which is this one over here, right? And the thing is, at one point, you damage it. It's super soft. It's good for my mouse. It's good for me resting on it, but it's not good for things like this. And that's the reason why I took a look at that one. And I think this one is I would say plenty for most people to be able to do most of the stuff that needs to be done. Because obviously what you need to do is you need to be able to solder and do a couple things like that. However, this is where the other piece is going to be making the difference, I would say. This one, I don't know how well it's going to show up onto the screen because it's quite big.
You know, having a nice mat like that, it helps a lot because, frankly, for the majority of my electronics, I did all of my soldering just on top of a big sheet of cardboard. And it's not ideal because your parts slide around all the time and things are rolling off your table and things like that. Having a really cool little silicone mat like that is great because, you know, it's heat resistant, it's electrically insulating, right? So you're not going to get stray voltages off of your table and stuff like that. And it has all those nifty little compartments. So there's a lot of really nice things that having a mat like that adds. And I mean, correct me if I'm wrong, it probably didn't cost that much, right?
For the mat? No, it was $20.
Yeah, that's cool.
Yeah.
I might be in the market for one of those.
Yeah, the blue one I just showed. This one is a little bit different. It's another one that's there, but obviously, as you can see, there's stuff to it, right? So basically, that's a middle piece right there, right? The bottom part, and that clips on it, right? And then now I can lift the whole thing up. It's super strong, and I would say quite good so far, right? It comes also with a light, and I guess you can see.
Oh, nice.
Yeah,
we got it for a second there.
Yeah, it was good for a second, and then bang, it just like, but you can see like it's magnifying glass, so it's going to make it easier. But also on top of that, it's a light, like kind of a ring light. So if you give me a second, I'll plug it in.
Yeah, and what's really cool about having a nice magnetic board like this is that you never really know what shape your circuit board is going to be or what you're working on. So having things all just infinitely adjustable like you get with a big magnetic plate is awesome. I'm super jealous, JF.
Yeah, you can see
this
how
is
big
sweet.
This is. Hey, take a look. I'm going to take it off. That's how big it is. Like you can get it compared to me. Obviously, I'm not like 6'4" or something like that. So it makes a difference. But still, at the end of the day, that's what it is, right? And I think it's just like it's insane to be able to have something like that. And you're completely right as well, like using a cardboard. This is something that a lot of people would actually use. If you're building up a computer, most people, what they do is they put, what's it called again? Their computer, their motherboard directly onto the box of the motherboard to be able to start building up. So if you look at Linus Tech Tips, for example, which is one of those famous YouTubers that builds up computers constantly. That's what he does all the time. He put it there and then builds up the computers, put the CPU, put the depending if he has like an actual cooler or something like that, he's going to most likely put it there to be able to keep building up the computer. So that's something that you have to keep in mind. If you don't have even 20 bucks is too much for you, use a cardboard. Everybody has cardboard, or just go to a store and ask if they can get one of those boxes they're about to throw out. Probably some of them are going to be like, yeah, sure, take them. So yeah, good. Very good advice over there, Four-Way. 1 second.
I'm glad being broke finally helped me out.
Well, I mean, we all start somewhere. Not everybody is coming from a rich family. Not everyone has a ton of money available to them, right? I'll be honest with you. I was lucky enough at one point to be able to buy my soldering iron, right, that I showed you earlier, but I was working for it. Even though I was 15, I was working for it. I was trying to figure out a way. And then eventually I found a job kind of deal, right? I made my own my own job, which was modding PlayStations. So that's what I discovered, and I decided to go with that. And with this, I built up some of the other equipment I bought over time. So this is a way that sometimes, I mean, like, I'm not saying modding, that's what you should do. What I'm saying is there is a job out there that you can start yourself and you can build your own business this way. And this is how I started when I was like 14, 15 years old. So keep that in mind. That's something that's going to be very useful for you.
Yeah, and even if you're not making any income off it, you've already mentioned like how you can save some money, right? Like you were able to repair that monitor by just replacing a single part that costs like 10 cents. So, you know, there's ways that you can save money in your life by being handy.
Yeah, exactly. Go to the e-waste we talked about, the junkyard, and find devices that are over there and trying to see if you can fix them.
Yeah,
that's something that might be very worth it. And then you have your iron, you fix your stuff, you sell them afterwards, and it might be good to go, right? So you paid nothing initially to get the acquisition of that device. Obviously, if it needs power, it might be a little bit harder depending on what power supply you need or whatnot. But that's something you can take into account, and then eventually you sell those things to others and you build up reputation, and customer service is very important, by the way. And that's all. That's where it starts. And then as you are making money, you can reinvest onto other devices, other tools, and so on, which is exactly other stuff like that I bought recently. The reason why I'm able to get this, because I reinvested into other locations to be able to get there. And I thought it was really great to also be able to share this with you. So either way, let's keep going with this. Very good thinking. And then make sure that if you are not sure, into the chat. Oh, I should probably remove that comment there. Sorry. We didn't get any answer from Jake. So for now, that's fine. But what I'm saying is, if you have any questions about devices that we're showing you up, what are other solutions potentially you could use that are a lot cheaper than what we're demonstrating over here? Because obviously this set over here, the whole thing, it's about like, it's over $100. So this is on the overpriced side, because obviously not everyone would need that. There's many other things that you could do. You don't need all those fancy things. I'm going to show you why I bought this, right? So first, the ring light. There's a couple of settings you can go for. So you can see here, I can turn this on, right? Can turn it off. And we can play a little bit with the lights, turn it down and turn it up. So obviously not something super fancy, but something that can be very handy as you are trying to figure it out exactly what's going on. So for example, if I have this little things here and then I need to take a look at it, but there's no whole light, like a ton of light to be able to see it, I'm going to be able to see it with this light, right? So it's going to be helpful for this. So that's one of those things that can be very helpful. I'm going to keep the light here on the side a little bit. Next things is, let's say we have that little arm over there. You can see here it's a shape, kind of a clamp shape, right? Where you can just like turn it around. And let's say for right now, I want my board to be around this area and I want to put it there, right? All I need to do is I can do that. So when Four-Way was talking about having helping hand, that can be one of those things. So now if I need to play a little bit around the board, I have it a lot closer to my hand. Well, I need to move my mic a little bit, sorry. I have it a little bit closer to my head. And then if I need to keep my iron and then a wire together and put them there, it's much easier to be able to maneuver around. And then now if I I'm not sure, and I need to take a look at the board and be able to see exactly what's going on there, that's going to be much easier for me to be able to see. Like right now, you don't see the how magnified it is, and then also the not the zoom, but the focus is not working really well with this thing, but that's fine. But it's just to show you that, and if you want to take my word for it, you're going to be seeing a lot better with this, right? So eventually, what I'm looking at, if we keep going with this series over here, this is only part 2, as we're discovering parts and so on, I'd like to be able to buy a microscope with HDMI, and then I'll be able to show you guys exactly what we're going to be doing with this. So good. So you can see here, I have it there, and it's easy enough to be able to just like unscrew this, move around, right? And then just like put it somewhere else, or put it like that if you want to. So it all depends how you want to do it, right? So how helpful would it have been to have this with you at this point?
Oh, totally. Yeah. And the perennial problem with soldering anything, and I'm sure Jake knows this, right? Playing around with electronics a bit. So in one hand, you have your soldering iron. In your other hand, you have your solder. Maybe you're also holding flux. You need at least 2 more hands on your body to be able to hold the board and whatever you're trying to solder onto the board. So it's essential that you have these kind of assistive things, like these helping hands, these clamps and stuff, to be able to do all those things and hold them in a secure enough position that you can make a nice solder joint, because things need to stay still as they're cooling down. And these having a nice sturdy arm like this one with the clamp on it to hold the board, and then having more highly adjustable ones like these little bendy tube ones that are off to the side, it makes a fantastic combination. So just, I know I'm beating the horse to death, JF, but I love your setup. I'm so jealous. I'm gonna be coming over to your place to solder some stuff next time.
anytime you want to, you just come in, just ring the bell. If I'm awesome. If I'm home. But you can see here, like, I mean, like, I'm just throwing things over here, right? I don't know if that would be the actual use case. There's probably like wires you could take, right? But let's say you need to keep it there because you need to do something else, right? So if I put it on 2 different things for now, it doesn't matter. Like, it's not going to work. But now I have this set up to be able to give me exactly what I'm looking for. So if I'm working on to another piece or another part of the board, and I want to know when it's going to be working, for example, right? Now it could be working. I don't need to hold those probes. I don't need to drop that down, try to make a modification, then drop down my stuff, then take again those 2 probes, put them back into where they needs to be. And then you see what I mean? I guess, well, I mean, like for you, for sure, for a way, you already know what I'm talking about, but I'm quite sure for a lot of people, maybe it's not something they thought about. So having those little helping hands like this, it might simplify your work tremendously, right?
Yeah.
So we're good with this. And that's those little things I was talking about that are going to be very helpful. Those little alligator things. Those alligator things could also be used to, depending on whatever use case you need to, maybe to hold as well the board. Obviously, they have rubber, so they're not going to be conductive as long as you don't go up to the end. So it should be good to go. So if you need like this, that's going to be another way to be able to do that. So obviously you use a use case. Well, you use it the way that you want. That's going to make the most sense for you, and make sure that you can advance your work actually. Okay.
And the little rubber tips, it's dual purpose, right? Because not only is it insulating electrically, but also it means that everything is a little squishy. Everything has a little bit of give to it. So like, say like you had just a second ago, you have a probe in one of the bendy arms and it's being pressed against the board. Well, it needs to press against something, right? If both the arm and the clamp that was holding the board are perfectly hard, that connection wouldn't work. It would be too faulty. But the fact that they're both a little bit squishy means that they can be pressing against each other firmly, and that makes all the difference.
Very true. Very true. All right. So this one seems that it's not going to work 100%, but it's very close, right? So that's one way we can actually have those things. So you saw those little probes that we have there. and then I have holes in this board. And one thing that you kind of told me when I showed you that thing is like, it's basically you can put directly like into the holes, right? So they're made for that. This location should not be a part where I should be conducting at all, right? Correct?
That's right. Yeah, definitely. And you can see that visually by seeing that there's no PCB traces going to those parts.
Yeah.
That's meant to be usually like a nylon standoff that keeps the board away from the rest of the chassis. And in the TP-Link router that we were looking at, you can see the little plastic tabs that are holding it in place.
Well, this one is D-Link.
Right. Yeah, but it's the same. You know, a circuit board is always held in place by some little posts like that.
Yeah, correct. A lot of times we're going to put screws through it as well.
Yep.
So yeah, so that's good, and that's how we can use it. Some other use case, depending on what they have, they may have different things in this. Maybe not exactly that. They might put it right there, right onto this little part. But a lot of times that little part here is going to squeeze and keep it there. So I would say that probably those ones, the other one I'm talking about, might be a little bit better than this. So it's not too bad. Could be worse, but in our case, we're should be pretty good to be able to do the soldering there on boards like this to be able to move forward in this case like that, right? And then again, we can use our little handy hands basically to be able to do something else as we're moving along, like I said, holding a cable or putting anything else somewhere else. So again, the other use case could be, yeah, exactly, putting a cable there to be able to solder it to a location. So you don't need to hold a cable, because you may need to hold the iron and then may need to do something else in the meantime. So that's another thing. All right. The next thing that comes onto that board, again, this is all options. You don't need to use one more than the other. You always use the one that is going to be much better for you, right? Again, for your use case. I don't know if this one's going to fit, but this is basically to be able to hold a board. Normally, they're saying we should be holding it like that, but let me see.
Can you slide it in from one side? If it's
it's a spring over here, so I might be able to just squeeze it in. There we go.
Yeah, see, so we have another spring-loaded thing, which is, yeah, it's kind of the same concept, but with actual metal springs this time, instead of just a squishy piece.
So this one here, you can move it around. Again, it's going to be staying there, right? But you can just like hold it up tight over here. You can make sure that this one's not going to move either. Just like, I don't know how you call that, those butterfly things. You tie them up like screws, and then you leave it there. And now we have full access to that board. And it's not even moving, right? Oh, well, I mean, like up and down might be moving, but like this normally should be good to go to be able to do whatever you need in this case. And then now you can use other hands once more. Right, so that's basically the reason why I bought this this mat. Everything was coming together to be able to make it as simple as possible with all those little pieces here. And as you can see here, well, maybe you don't really see, but it's another, hold on, I might be able to bring it a little bit over. There we go. So it's basically a flap. There we go. Okay, so it's basically a flap where you can put all your stuff in, okay, and then just like close it up afterwards. But basically, it's everything is the same as everything else that I showed you a little bit earlier. Let's move this. Okay. So you can see that there's a lot of different devices or a lot of different tools that I've bought. Not everything is necessary. So obviously I'm going with what Matt Brown said and buying a little bit more extra stuff to be able to go even further. So we're going to be able to experiment and see how much money we need to spend to be able to do X, Y, and Z, especially when we're trying to do our hardware hacking and then go even further, right? So obviously this is the device, the TP-Link we're going to be doing first, which should be rather easy because pretty much everything is there right in front of us. And then it has been reported as well that the security is not that great on that device. So we start with easy mode, and then eventually we're going to grow up as we're getting better and better onto those devices. Do I have anything else?
Don't sell us short, JF. Easy mode might not succeed either. We'll see, buddy.
Yeah. No, you're right. A very good point. Very good point. Easy mode might not be the easiest one, and we might knock our head. but we
Stuff
want to
is
start
always
easy
easy
mode.
in theory, but when you try to actually physically get into something, there are always like 1,001 complications. So we'll see. We're doing this live.
Yeah. I'm not doing it right now. This is part 2. My goal was to show what I bought lately and how far we think we're going to get. So next, like part 3 is going to be a little bit later, probably not today. We'll see. I need to get my stuff a little bit ready because I think I need to do a minimum for the stream to be able to keep moving. But obviously, this is something that's I want to be able to demonstrate live and do with everyone, because the goal is to be able to teach as I'm learning.
Oh, definitely.
So,
I just meant like when you're doing something, when you're actually trying to apply your theory to something physical, like soldering something to a board. Don't freak out if you encounter problems like, oh man, like this wire is too thick and I can't fit it through this hole. Like that's the stuff you run into, and that is the stuff that will cause you all kinds of trouble. JF has done an absolutely phenomenal job in finding a good kit to start this task with, though. Yeah,
we should be good. Should be good to be able to start this. I'm very excited to be able to to see how far it gets. Hopefully it works with Linux. If it doesn't, I have another SSD I can put into my computer and then pop on again like another machine. Like do I have Windows 10 on that one? I think I have.
It will work with Linux. You know, where this is serial communication. Once it goes through those wires, it doesn't care what operating system is on the other end.
Probably. I'm quite sure you're right on that. So that's something I'm going to do a little bit of research before I get on stream, and then and go from there. Just so we can move along a little bit more like seamlessly, if you understand. Is that the right word? But like as seamless as possible. So you're just not there looking around me trying to read online constantly and over and over and over. I'm going to try to bring a little bit more stuff so we can be as organized as possible, like right now, or somewhat like right now.
No, I hear you. That's a good way to be. We want to keep this interesting.
Yeah, we want to exactly, and that could be good to potentially build up a course eventually, like I mentioned with this.
Maybe
eventually.
Yeah.
So we'll see. Do I have anything else? I'm trying to think if I had anything else. A lot of people is going to tell me, Jeff, that's enough. Well, probably my wife would say that. More than anything else. No, that's about it. I'm very interested to take a look at those things, especially the multimeters, and see how where's that one there.
And you know, having a good interest in something is so much of the battle, because having a lot of interest in a topic is going to keep you motivated. And sometimes it's as simple as that. Like you bought a nice tool and you want to use it because it feels good in your hand and you just want to try it out and see all the features, right? It means a lot. Yeah, exactly. And one of the things is, I'll just switch over here. So I bought this one here, the Astro AI, right? I showed you about the fact that the sound does not resonate fast. It takes like a good second or two to be able to go through this, compared to, for example, this one. So the thing I forgot to tell you is when I saw that this morning, I bought another one of this. $17, right? Okay.
$17 that resemble a lot more like this one and not an actual AI. So now I'm wondering, is this one because there's so much stuff going on and the processor is not fast enough to be able to understand what's going on? That could be the reason why it's delayed like this. So that's why I bought the other one that looks or resemble more like this one. Still like a nice screen, and then we'll see. It's going to be next week. Thursday. I'm going to receive it. But I'm probably not going to do any stream before then. So, or after. So it's probably going to be like a little bit later. I'm going to show it and then and tell you my findings about it a little bit.
Sounds good, man. So whenever something is taking any kind of measurement, there's always a sampling time involved. And with this AI powered unit in your hand, like it's trying to figure out what you're trying to figure out, which is a bit of an open-ended problem.
True. But the thing is, like, I select the actual thing I want, right?
So that part you'd think it'd be just as fast, but
so if I leave it like that, I don't know if it's going to do. Are we seeing it well enough? That should be well enough. So, for example, if I put it on that shield, we should have a good connection, right? So when you see the 0, oh, that was fast. I'm surprised now.
Maybe because it already knows what mode you're in. I don't know.
No, it's on auto.
Yeah, I know, but it's like, oh, you're trying to measure resistance. Oh, you're probably still measuring resistance 1 second later, right? It just.
But look, if I take those two together.
Yeah, because maybe it's like, oh, is he trying to see that it's 0 volts when they're connected, or is he trying to see that it's 0 ohms? I don't know.
I don't know, but that's the thing I was wondering, right? Because it takes a little bit of time, and you can see, oh, it beeped.
Yeah.
Hold on. I'm gonna push this one a little bit over so you can see more. But if you see the light, yeah, okay, you should be able to see the light. Like when the light is green, that's when it beeps. Oh, there, it took a while, right? If I do it here, it goes much faster.
Yeah, it's probably a much cleaner measurement when you're checking the port housing like that, because it's going to be a pretty solid connection. When you're holding two probes together, we might think it's pretty solid, but there's actually a lot of electrical noise and just kind of
okay
microscopic like crackling between the tips. So yeah, it is what it is.
Let's do this one then. Okay, so this one we know, like, for some reason this one works fine, but obviously this is not the same company, same exact thing. So it's much faster, but it's still much faster than this one, but this one is much faster, probably for what you just mentioned.
For what it's worth, I still use this little guy that I got from the source or something in like 2010, and there's nothing wrong with it. It's a little cheapo thing, but it connects well to stuff, and yeah.
Well, it's the same thing as the other one that was showing up. I'll take it.
Just whatever you do, don't go and buy the like $1,000 multimeter, the like Fluke or whatever that they're trying to sell you.
I was actually thinking about buying the Fluke, right?
Oh no, it's for electricians.
One that I know actually works, or at least should work. And then when I saw this one, I was like, well, this one is $50. The Fluke is about 380.
Yeah.
Is it going to be worth it? Maybe. I don't know. Should I? And then I told you about it. You're like, no, you're crazy. Don't buy that.
Yeah.
Where's the other one? Hold on. I'm looking for my other multimeter, like the very basic one with the dial on top of it, and then see the difference. I'm not seeing it. Hold on.
So the having an analog multimeter like that, it's fine for like if whatever you're trying to measure is pretty steady. But if it's a voltage just kind of swinging around a little bit, you know, that arm on the analog multimeter, it has to move around. So it has momentum to it, and it's going to kind of mess up your measurement a little. So in this case, digital is maybe a little better than analog. But if what you're doing is like checking, do I have a connection? What's the voltage of this battery? You know, things like that are pretty steady measurements. There's nothing wrong with going the analog way.
Yeah, because we can see here, like, obviously we don't have any beeps, so it's a little bit different, but we still have the same type of deal that tells us that we have connections.
Yeah.
Right. So we have fairly similar in that.
And that's actually a little faster than the AI one, right?
Yeah, exactly.
It's going straight to 0.
As soon as you press, you have an actual result that comes in.
Yep.
Right. So super fast. This one here, take it back again. This one was dangling down. You can see if I, let's say, leave one there and then I press.
Oof. Nothing.
Oh, okay, there we go. But that's an issue. That's an issue. You understand why? I mean, like, I'm quite sure you understand. I'm just asking the kind of questions to the audience here. Let me move this because it's kind of annoying to have it in the way. But the thing is, I mean, like, it's automatic. Like, I'm looking for something that's going to have some results, and it doesn't seem to be able to find it. So obviously it was on auto, but now Let's put it back to manual. Again, this is the Astro AI, right? Kind of deal. So if I put it there, and then now I do this.
And this is how you know we're not doing sponsored content.
No, and nothing is sponsored over here.
This is a real test.
Nothing is sponsored over here, that's for sure. So no, it takes a while before the device takes it. Like if you are trying to take a look at all those little legs, is it going a little bit too far right now? Yeah. So if we're looking at all those little legs over here, okay, and then I'm trying to see if there's like connection between the two, it's going to take way too long because now I need to make sure that my device has the proper information, right? Especially with this Astro AI. If I take this, we should have a little bit more of an information. Hopefully it works. And then we just have to take a look at the top here and then see how it goes. We see here we have connection. And earlier with the Astro AI, I had nothing. But how tells me that there is current going there. Obviously, maybe some people is going to tell me, okay, maybe that's because I need to pay more attention to the screen over there. But if you're expecting to get, but if you're expecting to get a noise, I guess you would have maybe, oh, that's exactly where I was.
Yeah, and what I was saying earlier when I was talking about power supplies and setting yourself up with even a cheap but reliable power supply, it still applies here, right? To start off a task like this, it's like the very first thing is to be able to trust your tools, whether that's a power supply or a multimeter or your wire strippers. So yeah, starting off on good footing is going to make a lot of difference.
Yeah, exactly. So it's interesting. I mean, like I'm discovering that thing at the same time because obviously to me this is good that I'm trying to figure it out what those devices are capable of.
Mm-hmm.
Okay, so this one is not beeping either. Okay.
Well, do you know what that pin does? Right?
I have
it might
no
be connected
idea
to something totally. Should we look up the data sheet? Do you have a chip number for us?
I mean, that's the chip number over here. I can probably. Do you see it? No, probably
no,
not.
Not even
You
close.
Want me to write it?
You want to pop it in the chat or something like that?
Yeah. I can pop in the chat. I just need to take my keyboard.
So what's really cool if anyone doesn't really have experience with this, chips always have a part number on them, and it's very, very common to see the same chip manufactured by different companies, but they'll all have the same specifications. They'll be the same size. So when you find a data sheet for one of them, you're kind of finding a data sheet for all of them. So we just need to be able to start with what the correct part number is.
Okay, it's coming up. 1 second. 2, 3, 4. Yes. So this is how it's displayed right now on the chip. Okay, so you see the first part of the code. Yeah, on YouTube it can. So on YouTube it brought them together. So unfortunately you see them there, but it goes to AX. Okay, so 40ST 1041AX. Then after that it goes to a different line, and it's 0234S.
All right, let's check this out.
As you can see, like that probably. Yeah, there we go. Oh, you see it reversed. My screen is flipped. Let me see if I can change that.
So I got it right away. And JF, thank you for for distinguishing where the break in the part number was, because I just popped that in double quotes into a search engine and got the data sheet right away.
Okay, good.
Yep. So yeah, let's open this up.
There you go. So now if I would show it, yeah, there we go. Okay. I had to unmirror my camera for some reason. It was doing that. So you can see that's the chip here that I just shared online. You looking into it right now?
Oh yeah, totally.
put it back. This one back over here.
It's a 10/100 base quad port pulse transformer.
Are you?
So this is not where the firmware resides, right? But it's an important part for doing the coupling for the signals on the board.
Yeah, I see what you mean.
I was just trying to figure out what the ground pin is, because obviously this chip, it's on the board, it needs to be grounded, so we could check the resistance up to that ground pin.
Oh, okay, so
I'm going to be a sec. Yeah, sorry, man.
No, that's fine. That's fine. I was just curious, and that's something that we can check up. Is there like a website of the data sheet that you can share?
Yeah, sure.
Just share it on YouTube. Or
gotcha.
yeah.
Okay, coming through. Okay, so this is actually, you pulled a bit of a weird chip. Well, yeah, if you look at any of the the pins, CMT1, CMT2, CMT3, those are all going to be grounded. So otherwise they're differential lines. So this is not, it's a weird chip. I'll be honest. This isn't like something you would see in a regular breakout board or that a hobbyist would normally play with. But yeah, so if anyone's interested, chips like this, they're always numbered from, there should be a dot on the chip, right? And then you go, what would it be? Clockwise around the chip, and that's how the pins are numbered on the chip. So JF, how many pins are on one side of that chip?
I don't know. There's probably like 20.
Looks like exactly 20. Cool. So you can check pin. Well, pin 2, if you can find it.
Okay,
and that should be grounded.
I put it this way, so let me reverse this back so we can, like, you guys can see actually how it is. I'm gonna have to reverse it a little bit. Am I able to zoom in? No, that's the most I can zoom in right now on this camera. All right, so you said clockwise, right?
Yeah. So start at the dot, and whatever pin is closest to that, that's going to be pin 1.
Where's the dot on this one? So I see a dot there.
There should be a dot in one of the corners, yeah.
In one of the corners? I don't see any dots in the corners.
Okay.
Keep in mind, it's super old.
No, this hasn't changed.
There was no standards at that point. Well, maybe that's the dot there.
Well, hold up. Let me check.
Because that one has the same type of thing and does not have it. Well, it has a dot, but just there. That's
that's the dot.
This chip has one dot over here. That chip has one dot over there. This one, it has 2 dots, but depends, I guess.
Yeah, so that's marking pin 1, right?
Yeah. So this one would be.
You started us on a really weird chip, dude.
You're welcome. Anytime.
Yeah.
All right. So as we can see here, that would be pin 1, I guess. And then we need to go clockwise or counterclockwise?
Just whatever's adjacent to it.
Okay, whatever is adjacent to it. And which pin?
Here, let me check again, see if there's one that's easier to access. But pin 2 is probably the ground of the one of the ports. Hold up. Try pin 39. So if you go all the way around the chip, all the way around 39. The chip from the dot, and then find the second furthest one.
And what are you looking for? You're looking for voltage, or you're looking for the beep?
Yeah, check the resistance between that and some ground point on the board.
Okay. 39 would be this one if it's so there's nothing.
Stream. No?
Hold on. Let's take a look at the other guy here. Our super AI device that looks like a phone. But it's not a phone. Let's bring this up over here. Again. No. All right, sorry. It's going to be a little bit upside down for now. I'll tell you exactly what's going on. So 39 bring it up there. What do I have? Oh, let's put it back to auto. What are you going to tell me? Oh, you freak out now? Okay.
Oh,
It's nothing.
no, that's weird. Tell you what, a much better place to start, Jeff, is on the
top one.
Regulator. Okay, sure, cool.
The top one I have like 156.7 ohm.
Okay, so it's definitely not grounded. That's probably one of the signal pins.
Yeah, the second one I have 156.7.
This chip we're looking at is like electrically, it's between all those 4 ports.
Yeah.
Actually, probably all 5 ports and the whole rest of the board. So okay. It's kind of furthest away from what you would think of as like the beginning of the board. If you want to start somewhere easier, I would start with the regulator, which for us is the bottom left of the screen. How do I know that? It only has 4 pins on it, and it has a big heat sink on it.
A big heat sink on it?
Yeah. Well, sorry, not the huge heat sink for the big square guy. I mean, in the bottom left.
Hold on. Bottom.
Yeah, see all those capacitors? Yeah. Close, but the bigger guy. Yeah. That should be a regulator.
Yeah. Okay.
So check each of those pins, and one of them ought to be ground.
I got nothing. I got 150.5 ohms.
Okay.
And then the other one says 87.5 ohms.
Interesting.
The first one, okay, it's recording because it keeps moving all the time.
Yeah, so when you're hooked up, a pretty normal way to make a board like this is to put a capacitor on both sides of the regulator there. So you might actually be charging up one of those capacitors with your measurement tool. That's why, yeah, and like if it's trying to auto range, like we know it is,
yeah,
it might be having issues. We should try the other multimeter for this.
Oh, the other one? Okay.
Yeah, I think so.
Okay. And which mode do you want me to put it on?
On resistance at the lowest. And
what's resistance?
So the little ohm symbol.
200.
So often enough, there's a separate feature just for the bell to ring.
I guess we shall see.
For the beep to occur. But yeah, 200 is fine.
Okay, I don't know if we're going to have a beep over here, but like the black should be on this part.
Yep, it actually doesn't matter which is which for this measurement.
So I don't have any beep, but I have, let's say, 150.8, similar to the other one.
Same, yeah. And then it was 80 something.
This one, there's nothing.
Okay.
Well, I mean, like this one was kind of charging, so I don't know if my device was pushing, well, the other one, the Astro AI, was pushing more information there. And then here we have 88.7, so it's not reading the same.
Interesting.
Yeah, that's interesting. If I do the same thing with the other one, and we're on their home as well. Press here. Are you guys able to see that?
Do you have a chip number for us? Let's just pick another random chip on the board. Like you could do that one that I suspect is the regulator, and just give us the chip number.
Oh, okay. Yeah. Yeah, I'm gonna have to. Do you want me to read it out or write it again?
Yeah, you can just read it out.
Okay, so Alpha, India, Charlie. So that's one line.
Mm-hmm.
Then after that, 1084 Charlie Mike, and then a different line, 770. I'm assuming.
Yeah.
Foxtrot 9. Or over the radio, normally we would say Niner with air traffic control.
Yeah, so AIC is the brand, and then 1084CM is probably the chip.
Okay. I'm going to untangle my mess for a second. Lower the camera a little. This one, I'm going to have to probably switch the lens, unfortunately, Jake. So thank you for letting me know. This is something that you're correctly right, that I think I'm going to have to lower that down a little bit more. So, well, lower it down. Sorry, not exactly lower it down. I'm going to have to change the actual lens of this guy. You see there's another camera here, right? So I brought it down. But that camera, I need to interchange this one with the other one. So we're going to be able to potentially have something a little bit better this way.
Okay, so that is not actually the regulator. It's one of the more high power transistors on the board.
Oh, okay.
Yeah.
Hold on. Oops. I'm going to have to fix this.
Yeah, sure. But so even though this is not the board that we meant to really start with, this is kind of the beginning of mapping out what's on the board, right? Reading out every single chip number, building yourself a little library of data sheets. This is how we're going to get started and really understand what's in front of us. Thankfully, Jeff has already done his homework and knows exactly which chip we're supposed to be able to pull the firmware off of. So that's awesome. But if you were going into this with zero knowledge, this is how we would start.
Yeah.
Is by reading off part numbers.
If you give me 1 second, I
sure.
I have another lens, but I'm not another pair of lens. I'm not too sure if that's going to be too close, but if you give me a second, I'm going to give it a try. Might be able to. Give me just 1 second. Well, 1 second. I mean, count a little bit more than this, but still. I'll be right back. I'm going to go get it. It's right in the back there.
So to everyone that's listening, is there a part or a tool or anything that you're really excited about? You know, obviously I'm sitting here just nerding out about all these cool things that JF bought, and I'm a little jealous. But maybe there's some other people that are just as nerdy as me out there. So I'm here, I'm on the YouTube live chat, and I'm on the Discord channel. For those of you on Twitch, sorry, I can't see you. Yeah, I want to hear what you guys think too.
We got 26 people right now on the stream watching us. So it's
that's nice.
Yeah, keep growing up. So it's great to be able to do these things constantly and then keep going like this. It's good. All right, let me just switch this right away. I got that. Hopefully it's going to work out fine. Oh, I should probably just put the cap before, because this guy's going to sit down like this.
Oh, and another thing about when we're looking up data sheets for certain chips is you can often have the same chip in different form factors, right? So if you punch in a part number and it doesn't look the same as what you're seeing visually in front of you, because usually there's a little schematic picture of the chip, that's okay. It's not always a bad thing. Usually the last couple letters or digits on the chip indicate what form factor it is. So for that transistor I just pulled, I knew right away that the middle digits were the actual part number, which means that the last few digits are probably the variant or the form factor. So that describes physically what the chip is like.
Look at that.
Oh, that looks awesome, man.
Yeah, I didn't think about that one.
Wait, I can actually read the silk screen on the board.
See?
Holy crap, dude. Yeah, this is high quality.
Yeah. I mean, like this one is a prime lens, so it's not going to be able to zoom in or out. But at least we're going to be able to take a look at that. So you can see, like, I can actually like just go there and then point exactly where I'm going. You can even like probably follow along with me. It's just the other thing too is you're probably not going to be able to see maybe. Yeah. I mean, you're not going to be able to see that. So unless I find another way to be able to bring another camera. Do I have another camera I can bring on at the same time? Probably not. Yeah, the other one I need to go picture in picture, for example. And that's,
we could probably just peek at it if you can find a way to position it clearly.
Yeah, well, obviously, yeah, that's,
I wouldn't worry about it.
That's a point. I mean, like if I just bring, are we able to see even?
I don't think, I mean, maybe I'm just speaking for myself, but we don't need the magnification. Like the picture also, like, it's already perfectly clear.
Yeah. Yeah. So this. There we go. It's going to be a little bit kind of, yeah, I can see now. Yes, exactly. I mean, you just brought me a good thing because I think you were telling me about it before for Way, and then I was like, I don't think I have any other options than switching the two of them. And then I just clicked as soon as you asked me, Jake. So thank you very much. Good. So now if I would have to do this, yeah, we're going to see it. There you go. Should probably just move my hands a little bit, but we're going to see exactly where I'm pointing at and how things are moving. So
a little trick, especially on a high frequency board like this, is when you look for the biggest pads of metal, those are usually going to be your grounding points. So if you find some especially large traces on the PCB, that's usually ground. So for us, any of the shiny area, like all of that whole area surrounding the transistor that we're just poking around at should be a ground pad.
Oh, talk about that?
No, that's probably what you just touched. I mean the actual like shiny green part.
Oh, shiny green part.
Yeah, like okay. If we're looking at a boat floating on the ocean, we're like touch your boat to the ocean and then touch the other two, something that we know is ground, like the port chassis, the housing on one of your ports.
I'm not
like touch the board itself, not the chip. That's what I'm talking about. Yeah, there you go. That. And now check the housing.
Like that?
So, yeah, usually it might be coated with something.
If I do this, both of them, okay. Like this should be conducting stuff directly.
Yeah, there should be a metal layer under there. So usually there's a really big ground pad.
Yeah, I see little holes, so I'm able to poke through it, and then
yeah, cool. And look at that, 2 ohms, 1 ohm, 0.
Yeah.
So that is a indeed ground pad. Yeah.
Yeah, okay. There's a bunch of little holes here and there, all across the board. Yeah, because normally, like if you at one point, I don't know, you take this one off. Yeah, we see it at the bottom probably, right? But let's say you take one of those resistor off, and then it takes off basically the pad. One of those things to be able to solve that issue, probably more on this side though. But one of the things that you can solve this issue, for example, if this one here goes bad, okay, over there, and then you tear off the pad, what you can do is you can just like scrape the top of it, right?
Yeah.
And then you're going to have access again to kind of a continuation of the pad. Then now, depending on where it's at, you might have to leave the pin there and then just take a wire from here, for example, to there to be able to.
Yeah. Sometimes you're breaking the connection, sometimes you're shorting it. So, yeah, it depends.
Yeah.
When it's surrounded by shiny area like it is right now, you would definitely be shorting off the board by doing that.
Yeah. Well, exactly. So,
which, I mean, maybe that's intentional, right? As you're doing your repair.
Yeah, exactly. I know I had to do something like this because you know that capacitor over here. Well, I mean, not this one, but capacitor like this. At one point, I was trying to kind of pull it, kind of yank it out of it as I was putting my iron. And then the thing is, I tore one, like the pads around or something like that. So I had to basically find another place, scratch it up a little bit, and then just plug it to this afterwards. I can't remember exactly, but something like that happened.
Yeah, that's a really good point. And when I was saying about like, when I was talking about having wires that are a little too thick, this is the danger, right? So if you accidentally overcook the board as you're trying to solder something or desolder something, the metal layer will peel up from the plastic. Because this is a cheap board. It's metal on plastic. It's not like silicon.
Yeah.
So it'll actually like peel away like a little potato chip from the plastic layer if you cooked it too hard.
Yeah, true. I never went that bad though. I don't know if my iron is able to do that.
That you'll admit.
Yes, that I will admit live right now. We can talk later if you want to. So no, that's good. Okay, so a board like that could be this. So in our case, if we would, okay, my Astro is telling me you need to turn it off. You're not using me anymore, so it was beeping. So if we were to, for example, I'll take this one off. So if we were to take a look at this board a little bit now, real quick, is it going to be better? I think it's going to be better for you to see it this way because you're going to be able to see it a bit more from there. Can probably,
I should start by safely removing the board from the house, because then we can get a really good visual on it, like you had with the board just a second ago.
Yeah, but I would need to cut these things off because I don't think it's good to remove the antennas, isn't it?
That's fine. Yeah, let's cut them.
It doesn't matter.
Little white plastic.
So we go full distro mode.
It is okay to destroy. Yeah.
Okay, good. Let's go full distro mode. I'm just gonna get my cutters.
Yeah. Awesome. Next probably like side cutters or something, which is usually for clipping wires. Often for a job like this, just breaking into some housing, I will use my little mini Dremel with a plastic cutting bit on it.
Yeah, over here.
And also, if you don't have any of those tools on hand, I also have a very crappy old soldering iron that isn't really good for anything else, but it's awesome for melted plastic. So cutting a hole gently through plastic is easy like that.
Okay, so for some reason, I'm not finding my other cutters, so I guess I have to find. I got a nice tool. I did a course. I mean, like I'm gonna switch. I did a course on networking. Oh, I see. Do you work on network? Jake was asking that earlier. I'm not too sure if he was asking that to me or to you. That's something probably to go a little bit more in details.
Yeah. I used to do some network stuff, Jake.
Yeah. So yeah, I got a nice toolkit that was provided to me. I did the course, and then part of the course was to get this toolkit. So I mean, like it's all about network, and then this one here, it's like tracing those network stuff.
Oh yeah.
So really, really good. This one is nice, but there's another one that's even nicer as I'm pulling up or getting to the place. Oh, that's a wire stripper for Cat5 or RJ45. That's a punch down tool. I got this one here. That's the other similar to be able to do the RJ45 again. Crimper, right? I was coming with it. I'm getting there, I think. Probably the last pocket that I need to open up. Oh, there we go. There's my cutter.
Hey, there we go.
Yeah, there we go. Exactly. But I had another one that was interesting. That would have been good to kind of show up a little bit more. Give me a second if I can find it here. For some reason I didn't see it. Oh no, it's there. Okay. So this one, just as because I pulled it up, I got basically 4 different things that are showing up, right?
Okay.
My switch here. So you're going to see 1, 2, 3, 4, 5. Okay, so those connectors are there. You just plug them in your house onto one of those connections there. And then the thing is, you plug over here, and that one is going to tell you exactly which one it is. So basically, if I do that, this one here, the map master will know exactly if it wants to focus again. No, that's it. You're done. It does not want to focus. Oh, there you go. Okay. So the map master, basically what it's going to do is, because I have number 1 connected there, it's basically going to say that, look, this is number 1. So now you can map all your network around the house with this. You can do that also on a at work if you have something like that. But that's what I think it's super great about this one. And that's a little manual. I don't think. Yeah. So it depends on what you need, but I have a little manual that comes with it. So anyway, let's go back to cutting or destroying.
Yes.
Okay.
So yeah, I mean, you got your little cutter. How about you also get the wire strippers, because they're going to be great for kind of like biting and crunching the plastic.
To crunching into the plastic.
Yeah, because you're going to have to snap that whole tab, right? So.
Okay. You're not talking about cutting this cable.
I wasn't.
Okay.
And there's a reason, right? It's better to pull it off with the antenna still attached, or if you can just detach, if you can unthread the whole antenna and just poke it through the other end, that's best.
If you take a look, I don't know if that's going to be good enough, but you can see that they are basically kind of stuck into it, right?
Okay.
So, I mean, I can probably put it out somehow.
Can you like unthread the antenna though? Because it usually just screws right on.
No, it's not. It's like it's $20.
Huh.
It would have been $30 with screws.
Yeah. Okay, that's interesting.
Yeah, I'm pulling on it, and it seems that it's potentially able to do it. I probably need like tweezers or something like that. Not tweezers, but pliers to be able to bring them together a bit more. But you know what? At the end of the day, this is basically a board that I don't care about.
Yeah.
And this, I wouldn't mind having to buy another one if I need to be able to keep testing, right? I just need to find...
But we do not mind destroying anything white colored in front of us. It is all sacrificial.
Say again?
All of this white colored plastic can be destroyed. We don't care about it.
Yeah, exactly. But I'm still looking for my pliers.
Okay. While you're doing that, I'll show what tool I would use if I was doing this.
Okay, let me change,
Jeff.
I'll change you to you, okay?
Yeah, sure.
When my mouse reacts. Okay, good. So there it is.
Hey, okay. So if I was doing this job, I would go straight to my Dremel Mini. Okay. So yeah, it just spins up. It has a little rotary cutter bit on the side. This one is specifically for plastic, so it's great for cutting through plastic. You could use any Dremel or any kind of rotary tool like this really easily, but this one, it's since the way that you hold it, it's really good for fine motions with your hands. So it's kind of handy for doing boards like this.
Good. So I found my cutters. Hopefully those ones are going to working fine. And I see that Jake was talking to you about the networking. So work on networks.
So yeah, Jake, I used to do a lot more network stuff. I did radio links between different long distance sites from each other, both designing the radio links, and then I would also like commission the radios. So back in that time, I would actually have to do a lot of serial communication and hooking up to a wide variety of equipment through a serial port. Usually because that's how you configure the devices before they're commissioned and you can be put in the field. So yeah, that's my background. It's not the typical network stuff that people normally think of, but just because it's a different physical channel, using RF going through the air, a lot of the principles are still the same as somebody that might work primarily on Ethernet or like big Cisco switches or something like that.
There we go.
Yeah, there we go. Just manhandle it, JF. That works. That's what we needed.
I always thought it was strong. Yeah.
Oh, that's perfect. Yeah, so those are some like pretty heavy duty side cutters.
Oh, I guess I'm gonna have to clean this up.
Okay, that's
it's
fine,
all flying. It's flying over the place. There we go.
As long as it's separate.
Say again?
As long as it's separated from the rest of the board.
Yeah. No, I just want to make it a little bit more like round and not sharp. If you understand what I mean? So I don't hurt myself. Not that I would or that I want. Am I able to cut it there? You said the white part was not good, huh? So it doesn't matter. Okay.
Just leave it. Yeah.
Yeah, leave it like that for now. And then let's keep cutting over here. Let's go destroy mode. Full destroy mode. Are we seeing it here? I mean, like we need to catch this.
Yeah, that's good. Just don't cut any wires. Yeah.
No wires.
So for anyone that's interested, the reason why we're not cutting the wire is because the board usually expects a certain impedance to the antenna. So that's like kind of a fancy way of talking about resistance. So for any kind of wireless connection like this, there's always going to be a 50 ohm impedance.
Sorry.
And we want to keep that intact. So by not... Wait, did you just break it when I was talking about it?
No, I didn't break it.
Okay,
No, I can tell you, things are flying over here.
All right, cool.
Let me see if I can bring this one up. Let's take a look if we can get a replay later on offline. But oh, you see it? Did you see it? I saw it on the screen.
Goggles, people. You know.
Hold on, one more. Oh, it flew. At least I see it on the stream there on our streaming thing. Oh, another one. It's just like it's going. Well, one more. Too much fun. Sorry,
this is going to be JF at the gym this week. Just working on that grip strength, you know.
My God, I wow. To be honest.
All right, so why do we want to get... Oh, that's awesome. Yeah,
not even kidding. I carry that in my bag. It's always there, and then it's always trying to... Well, not always, but whenever I can, I try to work on the grip. There you go. All right, so nice. Now... sorry, keep going with your story. I cut you because I had too much fun.
Yeah, so I was just talking about, like, why are we doing this? Why are we removing the antennas and pulling this thing out of the housing? Basically, because we want to see the backside of it, and we want to be able to mount it in a lot more stable way. So Jeff just like a few minutes ago had that D-Link board sitting in that nice little, I think the technical term is board grabber. And we want to do the same thing with this TP-Link board. Because that way we're going to be able to solder to it, and we're going to be able to look at it through that camera really nicely.
All right, so let's remove this thing.
If it were me, I'd probably also kind of tuck away the antennas and maybe tie them together with some tape or something, just to keep it from being too, I don't know.
To not damage them?
From dangling around.
Yeah. Okay. Yeah. We'll have to figure something out. So maybe put it there. This one, bring it a little bit closer. We're going to use the spring a little bit for now. There we go. Well, now we're going to be able to take a look at that. I don't know if I use like what's it called again? A tie wrap.
That works. Yeah.
Yeah. I don't know if my tie wrap's going to work though.
Sure.
In that location.
Rubber band is great too if you have some sitting around. Hey, where was Jake talking? Because it's probably my fault, but is he in YouTube?
It says YouTube. It says YouTube. Man. But I don't know which YouTube. It could be Malvik, or it could be the one with Hack the Box Auto Meetup.
Oh, okay.
Right?
Dang. All right.
So there's two. In all right now we have 30 people. There's a lot of people in the stream. Most of the people on X, I don't know if they're able to talk. I know they're able to talk, but a lot of them are rather quiet in general when they watch us.
Yeah, that's cool.
So I guess I got tape over here like this. I have to figure it out a way to make it work. So right there. And then basically speaking, these ones, maybe if I just tie them up onto the plastic, not the plastic, but that thing might be something that's going to work there for now.
Okay. Hi, everyone. Sorry, I am now in the correct chat.
Well, there's four different chats, by the way.
Yeah,
if you didn't know.
You bet.
So that's the thing. We're streaming at 4 different locations. So. Okay.
Oh, so Jake, yeah, I got my name from the handshake that happens during WPA. So if you've played around with any wireless stuff, before you can encrypt your channel over your Wi-Fi, a handshake needs to take place, and that is the 4-way handshake.
All right, there we go. Let's tie this up together so they don't move too much, and we're not going to damage them more than I just did. Not that I did, but quite sure 4-way is not going to be proud of me if I don't do that correctly. All right. Let's put that back down. There we go. I mean, that's a good start.
Yeah, that looks great. I love it.
That's good enough. So we have to have that on our tab. 10 cents. All right, there you go. It's good. We have the board. We have a couple of things. This needs to be, yeah, it should be good. Should be good enough for now, at least. And then if we need to correct it a little bit later on, we can try to do that. Since it's higher from the ground, it's going to be easier for you guys to see.
Yeah, it looks great.
Perfect.
For the benefit of the audience and to the detriment of you, JF, do you mind turning the board around so we can read things not upside
Thank
down?
you for reminding me. That's something I should probably work on. If you give me a second, look. Give me a second. I'll try to see. Do I have enough cable around? This one is a little bit on the tight side. Yeah, I need to do a lot more. Okay, so no, never mind. I'll do that next time. I think it's a bit too much dangling around with the whole thing, and I just need to readjust it. But otherwise, like that for now. Let's work it out.
Awesome. And now that I'm just seeing these questions, programming languages, Python is my favorite. It's kind of my go-to whenever I need to get something done quick. I also work a lot in JavaScript, often in Node.js. But I use JavaScript a lot for when I'm doing web stuff. And my life started with BASIC, actually. So BASIC turned into C, and then I learned C++ after that. So kind of the .NET stack. Got into C# when I started doing a bit of game programming. And then just last week, I wrote my first thing in Go. So it's always changing. It's a great question, but my long-term favorite is probably Python.
And Python is a high-level code, which is easier in general. Obviously, you could go to assembly, which is much harder, but you could comprehend. If you can disassemble everything in assembly, would be better. But I think you're right. Like pretty much everybody now uses Python. It's probably one of the best language you can have out there.
Yeah, it's definitely the fastest for getting something done. But something like assembly, hey, if we're splicing into a board, that can be really, really useful.
True.
Because we might see instructions flying over different pins in assembly code.
Very true. Very true. There's also on Darknet Diaries, if you guys can remember. I've been talking about it for a while, but Darknet Diaries basically talk about that one of the those basically podcasts, and it's a girl that used to work for Google, and she knew assembly, and that's the reason why she was hired over there, and it's to be able to disassemble malwares and understand exactly what it's trying to do on Android devices. So. And then I think she went to Black Hat or DEF CON, one of the two. And she was there. So I think there's lots of good stuff to understand from assembly, but it's not something that's going to be super easy to comprehend for sure.
It's really tough. Yeah.
All right.
Assembly is like if you had to program something by picking up rocks and putting it in different bins and figuring out how to do math in that way. That's what assembly programming is like.
It's fun.
It is, yeah.
Okay, this one's not gonna work now.
All right. So what do we got here?
Okay, we're back to working conditions.
Cool, cool. Should we try out a connection if you want to try a known ground?
Sure.
All right, cool. So we got the UART port, those 4 pins that you pointed to before, right?
Yeah.
So we have a labeled ground right there.
Yeah.
And then actually, hey, here's a good question. Can anybody in the chat tell me somewhere else that we know is going to be grounded? And thinking to the most exterior side of the circuit is probably a good idea for this. We'll just give that a few seconds while JF is hooking this up.
Yeah, yeah. No, I'm good to go. So you want me to actually do the test over here? With
yeah,
ground?
Sure. Try something.
Okay. All right. So I got ground and I got the voltage. So I mean, like right now, I'm.
So that should be probably in the hundreds of ohms. Is typical for that.
I got 200.
Yeah,
that's the minimum.
Pretty normal.
Okay. So if we put it there, are we getting anything? Yeah, you can see here. This one's VCC. This one is ground.
It's ground. Okay.
Do I need to be powered on?
No, and it's better if we're playing around with it like this. Let's keep it turned off.
That's all right.
Yeah.
You're not my mom. My God. Okay, so 200. I think it's probably not working. So I see that there is nothing. I know it's kind of. Can I bring it like this? Yeah. Okay. So we don't see anything changing there.
That's cool.
Can I have it there or there?
Why don't you grab the ground from that port there, and then I'd say probably the easiest answer for what else should be grounded is right at the power plug. So the outside of the power plug is going to be the grounded side. Otherwise, I got the outside. It would be unsafe as you're trying to plug it in because you might accidentally touch it with the tip of your finger. So it's always going to be the exterior or something that's the grounded side for a cable.
Yep.
Yeah, so cool. And so you got 0?
I'm touching it right now. And then if I go to VCC, I'm getting 0. So let me see.
Right, but ground to ground.
A sound?
No, it's the second pin that's ground, isn't it? On the port.
No, I'm touching it here inside, right? With the ground.
Right. And
then the VCC is the top one. So you can probably see VCC right there.
Yeah, right.
And then after
VCC.
Oh, do I need to turn it around? No, you guys see it correctly?
Yeah, it's going to be all upside down and stuff on the board anyway, so don't worry about it. We can see the chip labels at least the right way around. But
but I can turn it around if it's easier for you guys because I realized that I thought it was.
Why don't you remove me from the feed and then we can see.
Oh yeah. Okay, good.
That'll help. Yeah. Bye everyone.
There you go. You're there. No, I need to change it differently. I need to change there, and there we go.
There we go. Yeah, cool. So take that second hole, the second through hole there.
Let me turn
one
it
right
around.
next to VCC. It's okay.
Everything correct this way.
Actually, yeah, I guess the majority of it is silk screened like this. That works. So
okay, that's good. And then I'm gonna get my 2 cables there, so it's gonna be a little bit easier this way. Come here. There we go. And let's move this one there. This one a little bit closer so you can see that there is something changing potentially. All right. So now if I go to, let's say this is the ground, right?
Yeah, let's do ground to ground. And then let's do ground in the power plug.
Ground and power plug. Okay.
Yeah, and ground where you just were. So one side on where you just were and one side in the power plug.
So we hear it.
There you go.
So
there's your short. So that's perfect.
Yeah.
Right.
So that's working. That's for sure. So basically speaking, if I hold this side and I hold this side, we should have something in between the two. Is that what you're
Yeah,
saying? I thought you needed to power it
you
on.
need to have something between them, because there should be typically for a board like this, there's going to be a few hundred ohms between VCC, which is your 3.3 volt or 5 volt or whatever. It's whatever the kind of power supply voltage is, and ground. Otherwise, you would have a short circuit and the board would not work. So you need power to flow through the board, so there needs to be some resistance.
Okay. Let me see. Hold on. Am I? Oh, I'm covering my face. I was wondering if I could get it on. Is there a way to turn off the names? Give me a second. I just want to see if I can take that off. If I can take it off, that's going to be a little bit better. Potentially. Layout? No? Oh, no, it's not working. Okay. Well, it's working somewhere, but I'm just going to put it on the side for now. All right. Because my name is there. All right, so we should, like you're saying, we should have something from here to here.
Yeah, you should have a few hundred at least.
I don't have anything, but if I need to put it to home, right?
So you need to put it into a range that's going to accept hundreds of ohms, right? So if you're on the 200, that might not be enough.
That's 200.
So I would kick it up to the 2,000 or 20,000.
20,000, you said?
Yeah, sure.
Okay.
Nothing wrong with that. It's just going to be a small number.
That's fine. So I don't see anything there.
That's weird.
You can see that.
All right.
Let me see with the Astro. Again, this is...
if you check that same measurement from the power plug, we might see something different, though, because one is before all the power filtration circuitry and one is after.
Oh, interesting. So when I do it with the Astro, I'm getting something.
Oh, so what's it showing you?
Yeah, I'm going to put it on screen. Is that going to be... No, it's not going to work.
No, just tell us.
Okay. Okay, I put it on it. Hold on. I'll let you know. So it goes in thousands of homes, and I got it at... Oh, it's moving. 37.7 right now.
And that's probably because you're charging up a capacitor.
Yeah, probably, yeah. And what about if I put it to voltage and keep it there? Because that's the way
that wouldn't be a meaningful measurement.
No?
Because there's no... The board is turned off right now. It would need to be on.
Oh, yeah, but you know what?
If you do want to turn it on, we could go check what VCC is, if you want.
So, VCC should be the power. Yeah, no, I want.
Yeah, exactly.
I want it. So the thing is, that's exactly what you were saying. I put the little plugs over here back on the board, and I was seeing voltage, but the voltage was going down. So I'm assuming that the capacitor, like you said, was pretty much like charging. And then eventually, when I removed it out of that, the charge was still there, but like very small. Okay, I just need to
for big capacitors like that one that we're looking at to the left of that little row of 3 chips. Those can hold charge for, a few seconds, definitely less than a minute. But it can take a while to dissipate.
Yeah. I need to find where I put that thing at.
Jeff, I'm gonna have to run pretty soon.
Okay.
When do you want to draw the line for part 3?
That's a good question.
Yeah.
Part 3, like, if we can take a look, potentially next week.
Okay.
That could be good to do probably either on a Monday or Friday.
That's exciting. Okay.
Because the thing is, it gives me a little bit of time to be able to set up my stuff, and during the week, it's hard if I have to drive to Ottawa and then drive back home, which is like 2 hours away. So I want to make sure that I can do that for sure. But if you give me 2 minutes, we can at least take a look at that VCC first, and then and then stop it there.
Sounds good.
If you need to go, you need to go, right?
No, a couple minutes is fine. But why not you could check it directly off the power supply. It's
Yeah, I need to
and
find
for
it
anyone
on
that's
Spotify.
listening, like it's good to check both sides
Mm.
of something when you're trying to do a measurement. So
So-
right now we're going to check the power supply itself, and then we can hook up the power supply to the board and check that what should be the same measurement elsewhere on the board.
The thing is, everything looks clean from this angle, right? You don't see what's on the ground right now and just all over the place. So give me
as long as
you
you don't have a cat, because this cat is going to be electrified.
I don't have a cat, so we're good on that. So give me 2 minutes. Keep talking if you don't mind, and then
sure.
I'll be right back as
can you give us the board again, and I'll give a little tour.
Yeah.
Okay, cool. So I haven't gone searching about which chip is which here, but I would be willing to bet that row of 3 chips on the inside are for interfacing between the rest of the board and the ports. Okay. Yeah. Yeah, Jake. But let's talk about the outside of the board here. So we already saw those 2 wires that are leading away from the board. Those are the antennas, right? It's a 2 antenna router. So that's pretty easy to identify. We also see the barrel jack on the bottom left. So that's for connecting your power. In one of those kind of old style plugs that is circular with a little pin through the middle. So that's what we intend to measure in just a moment as soon as JF gets it. And then walking around counterclockwise around the board, can anyone tell me what the blue port is? It's definitely a network port. And electrically, it's going to be connected to the rest of the board in a really similar way to the orange ones. So I'll give you guys a minute to answer that. And then as we continue around the outside of the board, to the right of the orange bit there, we see what is a button, right? So normally that button would be exposed to the rest of to the outside of the chassis. I'd be willing to bet that that's the WPS button.
Well, it is the WPS.
Awesome.
Yeah.
Great.
Well, no, not awesome because it's bad.
Yeah. WPS is notorious for being pretty insecure. Yeah.
And the thing is,
disable it.
well, if you're looking to be able to see how dangerous it can be, take a look at our last stream on December 19th when we did the Hack the Box Meetup 14. We have Wi-Fi Netic 2 that we brought up, and we were actually attacking a Wi-Fi device.
Exactly.
Through hack.
And this was what made it vulnerable.
Machine. Say again?
Yeah. This was the vulnerability that we ran into, if I remember right. It was we did a pixie dust attack on it, right?
Yeah, correct. That's exactly what we did.
Cool.
That's exactly what we did. So yeah, so I got the power supply finally. It was hidden behind the many things I have on the ground right now. I need to clean that later on. Are we going to be able to see it? So we see TP-Link. Yeah, good. That's good confirmation. I got the right one. If I take a look myself here, it's a 9-volt, 0.5 or 0.6 amp.
Okay. So 9 volts, eh? Interesting.
Yeah, you can see it. I think it's like just right there.
Okay. So right away, just knowing that one number, 9 volts, means that there's going to be something between VCC on the serial port. JF, if you could point that out to us.
The what again?
VCC on the serial port, just so people can follow along.
Talking about here?
Yeah, that guy is not going to be 9 volts. We know that right away.
Yeah.
So we're not going to see the same measurement if we're checking the voltage on that as we would see directly off the power supply. So we should see 9 volts on the power supply.
Are we able to see it even better like this?
No, but yeah, sure.
Yeah. So that's using my phone.
Super.
That we can see those stuff. I mean, like right now it's upside down for you, but you can see.
Yeah, 9 volts DC. Cool.
Yeah.
Yeah, you bet.
So that's the other thing I've been using lately to be able to help myself out when I'm trying to look at the board. Obviously, I said I had that little lamp over here, right? To be able to find out. But if you are able to utilize your devices, take a look. Hold on. Am I able to bring it on?
Yeah, that's pretty awesome.
So see how close we can get to be able to find exactly what we're looking for, especially when they're super small. I wouldn't recommend using that to be able to help yourself with soldering, but at least that's a tool I found out for myself on the go. Okay, keep going. Sorry.
Yeah. Well, so I was just giving them a quick tour around the board in the counterclockwise direction. After that, we're not quite sure what the chip on the top right does yet. The surface mount chip that's in the middle, the square one, this is definitely going to be the main processor on the board due to the sheer number of connections that we see going to it. If I had to guess, that chip on the right is going to be for it's a chip that you use between the processor and the higher frequency components, so the antenna and the ports. So that's going to be the like 100 megabit side is probably going to connect through that longer chip on the right hand side. The little guy with 8 legs, kind of to the bottom left of the square one, is what JF has already identified as holding the firmware. So it's probably going to boot off that chip. If I had to guess, that is an EEPROM chip. So just toss that into the chat. It's like, think of it like flash memory. But we'll see. Maybe it's a whole bootloader. We don't know yet.
So I'm gonna plug the device in. I'll be right back.
Sounds good. So yeah, now we're at, let's talk about the top edge. If anyone hasn't seen them before, that's what a whole LED looks like. So each LED has 2 electrodes on it. One is positive, one is negative. They are directional. So if you hook them up backwards, they won't work. Going around counterclockwise, yeah, we have the antennas, and then unclear what that little square one is. It looks like it's substantially taller than the rest. I'm sure we could get some numbers off that and figure out what it is, though. And then after that, we have a very large capacitor. So it's from the side, it would look like a tall cylinder. That's called a tank capacitor. So it's usually used for power filtration and things like that. There's capacitors all over this board, but they're just little guys, all except for this one tank capacitor, which is hooked up, unsurprisingly, really close to the power port, because that's going to filter out all the little micro fluctuations in the input voltage board.
All right, so I'm just putting a little tape here. That's going to be my my glove. Yeah. So, are you ready to go?
I'm ready.
All right,
yeah.
You're born ready.
I should probably go right after this. Oh yeah.
Do you need to see my face as well as I plug it in, just in case, right? Or let me bring it up there instead.
Just to make sure you're still alive, JF. Yeah.
Yeah. Yeah. Exactly. So good. I mean, like I never plugged it in. I don't think it's going to be an issue, but it's just so you know.
Well, hold on, man. Let's go ahead, unplug that, and let's check put the multimeter directly onto the power plug.
Onto the power plug?
Yeah, so it's negative on the outside of it and positive on the inside.
So let's go. I guess you want.
And this is where we use our helping hands, right? Because we need 2 hands to apply the probes, and it's best to have something else holding the plug itself.
So you want voltage there?
Yeah, definitely. Voltage, the 20 volt.
20 volt. There we go. Put it there.
And 20 volt DC, right? There's also an AC section.
This one?
Yeah, DC is with the
straight line,
solid line, and then dashed line under it.
Yeah, that's
yeah, you bet.
What I got. Okay,
cool,
good. So yeah, I think I can just do that, right?
No, use your helping hands because we need both.
We need both. Okay. Yeah. I got my hands.
Well, unless you grow a third one, we're gonna. Yeah, there you go. Cool. So now put the red one on the inside and the black one on the outside. Super. And what do you get?
939.
Awesome. So
that's what it is. Move the
it's within
little hand.
reason. Yeah, 9.40. Yeah, awesome. So it's 9 volts, guys. That's it. The rest of bringing it down to a predictable voltage on the board itself is handled usually by a regulator that sits on the board.
Yeah. That thing there, that's where the VCC is, again, over here. Technically speaking, this is what would be the indicator of which type of USB we need in this case.
Exactly. So, yeah, you nailed it. So we know that's not going to be 9 volts, right?
No,
it's
exactly.
Either
You're
5 or 3.3.
Yeah, and rarely I think there's 1.8 as well too, or something like that. 1.2. So either way, I'll plug it in.
Yeah.
So it's done. See the lights turned on.
Ooh,
good.
Blinky.
Yeah, and if we can remember exactly from that device there that I showed a little bit earlier, am I going to be able to see? So now the other way around. So we have the 1, 2 volts, and 3 and 5 volts. So we have a couple of choices we can have there. Those ones I'm not too sure what they mean. All right, so we can see here that that thing is actually working. It's a little. It doesn't look like that. It looks like white on the stream, but it's actually like kind of a orange. So it's a little bit different. So now I'm going to go and do exactly what we just talked about. So I'm going to put here that little prong into the ground, and then the other one under VCC. So we see 3.35.
Super, 3.3 volt.
Yeah. So we know that what we were saying was exactly right. So to be able to hack this one, that's what we need. Then later on, obviously, if we wanted to go a bit further, do I have those cable there? Hold on.
So probably for part 3 of this, we're going to build ourselves a little 3.3 volt connection to talk to that port through a computer.
Yeah. So could we just like kind of use these ones?
No. So that's not going to be a good enough connection. And whenever you're building a connection like this, we should do it with the board off.
With the board off? Oh, yeah, initially with the board off. Yes.
Yeah.
Yes.
We build the port onto the board and then hook it up, and then we can power on the board.
Yes, correct. That you're completely right for that. Yeah.
That's good.
Very true. At least that's what I know Matt Brown was also doing. So it's good that, see, you didn't see any of the Matt Brown videos and you already know that. So yeah, so that's cool. Let's do it again. So 3.35. Now, let's test the other one. Let's test the Astro AI. If we're gonna get the same thing, let's put it. Okay, the Astro AI can do both on the same setting, apparently. Yeah, 3.359 volts. That's still good. It went super fast to be able to tell me the voltage. Yeah,
cool.
So I'm surprised about that.
Nice.
Using the power of AI with the multimeter makes complete sense. So yeah, so that's good. I think this is a good first step that we've done right now.
So another quick check, if you want to do it, is go check the voltage across from those LEDs. It's probably going to be about. It's going to vary, but probably 1.1 volt.
1.1. So which one should I check? Should I check the?
Any of them. The voltage just depends on the color and the style of the
0.01.
Well, that one's not on.
Yeah.
Check the one that isn't blinking. That's probably the best.
Oh, no, okay. I didn't see for some reason this one I didn't see was on. So 1.94.
Cool.
I think that's what it is, right?
Yep.
Yeah. And then is this one going to be able to tell us the same thing? Oh, it's turned off. It turned off on its own. That multimeter is conscious.
It's trying to.
It knows about the environment. Don't.
Yeah.
So this one here tells me, hold on, why minus 1.94? That doesn't work. Is that?
No, that's fine.
That's
you
fine?
Just hooked it up backwards. That's all.
Oh, okay. That would make sense.
Yep.
That would make sense. So if I put it back the right way, 1.939. It's good.
Awesome.
And this one here was like 0.01 volts. So
yeah, I mean, it's essentially zero. Yeah.
it goes
an
in
LED
homes.
like that,
This one, it
won't
goes to homes,
function
and what
unless
to
you get past that
okay.
threshold voltage.
Yeah, this one goes to homes, even though there's nothing through it. It says it's basically 440 ohms, even though there's
yeah. So that's probably elsewhere on the circuit. That's not if you were to like cut that LED out and test the resistance across it, you would see that it's essentially an open circuit, like infinite resistance.
Oh, okay. That makes sense.
So that 400 or whatever you just measured is probably because of other resistors connected on the rest of the board.
I see what you mean.
Yeah.
Well, that's good. That's interesting.
Fun. So we powered it up. We checked a few things, and yeah.
So
we should probably call it here, eh?
Yeah. Well, I mean, like for you, especially, you need to go. So
yeah,
it's good. So if we
don't
just
do too much without me, though.
Why? Yeah, I can put that on hold for next week, for sure. But here, if you take a look, I got 3.3 volts. That's where the jumper is, right? And that's how we're going to be able to actually do it next week.
Nice.
Good. Be careful and don't die. We need you to live. That's good. No, Jake, don't worry. I'm still alive. We're still good to go. I was more making a joke than anything else. And either way, I put something here to be able to prevent me from having any issues. So now the question is, and I know the answer to that. I'm going to ask you the smart, intelligent, four-way answer. Even though I unplugged that board, is it safe to touch it now?
No.
Why?
Because of that.
I know. What's the smart answer? No.
Yeah. So as I was giving a little tour around the board, and we got to that big electrolytic capacitor in the bottom left. Like I said before, that thing can hold charge for somewhere on the order between seconds and like a minute before it leaks away all of that charge into the environment. So literally electrons flowing out of it into the air. Sometimes there'll be resistors and stuff to dissipate the circuit, but yeah, it's not safe for a little while. Sometimes you'll get in the habit of actually discharging components before you touch the board. But that's a little more advanced, and we can talk about it later.
Okay, am I able to just...
You're asking the right questions, though, to not die.
So I'm touching it right now.
Yeah.
Right? So it's basically just underneath the capacitor, and you can see the amount of volts that are going there.
Yeah. And that's going to be equivalent to the power supply voltage, minus whatever it's bleeding off as those micro fluctuations in the supply voltage. So it's not a perfectly flat line. If you're to think of like a graph of the input voltage, it's a little ripply, and all of those ripples get they flow through the capacitor. The DC component, the perfectly steady portion of the voltage, it doesn't even see the capacitor. It goes right past it, but the ripples go through it.
All right. So what I'm going to do is I'm going to unplug it right quick and then put the two probes right away after. Okay.
Sure. Okay. Be careful. Yep.
See, it's going down.
Yep. Cool. That's awesome. Yeah.
Yeah.
How much energy is in the house?
Define energy. Talking about amps, volts, and it depends also on your location, country.
Maybe joules. Yeah.
Or joules, maybe. Okay.
So that's hard to check, but actually the measurement that JF just did is exactly what we would need to check. So he checked the voltage across it, right? That's the voltage. So the potential, and then we could see how quickly it was dissipating. From that, we can measure the current that's flowing out of the capacitor. So the voltage times the current gives us the power, and then we divide that per unit time in the seconds of our measurement, and that gives us the energy. So we can see what the initial energy of the capacitor was through exactly the measurement that JF just did.
Nice. The other thing too, right now that you can, oh, sorry, Jake is saying 220 volts or 380 volts.
Jeff's in North America, so it's 120 in Canada.
Correct.
Probably more like 115.
Yeah, and I would say in Europe it's probably 220.
Yep.
And depending again on the country, I think, yeah, I can't remember exactly where. I think is it Algeria? I think it's around that area that you're at, Jake. So, yeah, so that's what it is. It says 220. Sorry, 120. Sorry, 115 normally volts into most homes here in North America. However, there is also a way to be able to get 220, but this is not the normal plugs that you're going to get. So if you
don't do it. That's how people burn down their houses. Just don't.
No. You're not supposed to have that.
Your utility plug off of your like washer and dryer. That's usually double the voltage.
Yeah, exactly. There's just only specific stuff that's going to have 220, but that's about it. Most of the stuff are all 115 in North America for sure.
Yeah.
No, good. So I don't know. Maybe
all right.
Bitcoin
this
server.
Is me. I gotta head out, guys. It was really nice having this session. This is a lot of fun, and I love seeing your kit, JF. You made some. I mean, I know you have a reputation, but this time you made some really, really top-notch purchases. So
that's good. That's good. No, I think at the same time, it's a good time to be able to hand the stream. I know you need to go. This is something that I need to clean up now. I need to do a couple of things. I might do another stream later on, depending on how it goes later on today. But right now, I think we've done almost like 3 hours. We're at 2 hours and 58 minutes right now on the stream, so which is pretty good. We'll see if I'm going to do another one. I want to do some cloud gaming and streaming at the same time, and just like kind of showcase as well the capacity of having devices such as a bad computer, right? And being able to play AAA games easily for a couple bucks a month. So either way, that's what I'm thinking about doing potentially at one point throughout the week. We'll see how it goes, or maybe during the weekend. Really appreciate having all of you guys showing up. There you go. I got your face over here again. I forgot about that. And then, so yeah, it's quite good. Part 3 is going to be coming up. I think part 3 is going to be a little bit more setting up the PC or Linux with the USB, and then starting to play around a little bit more with the board that we have over here with TP-Link. And I think that's going to be a great third event to be able to have, and then keep growing this interest and learning together how to hack hardware on the easier mode, right? I know it's not easy, but I know you told me that four-way, right? We're going easy, but it's not easy.
It won't be easy.
Exactly. Yeah. So good. Do you have any departing words that you'd like to say four-way before we?
No, I had a blast, and I'm really thankful for all the people that showed up and stayed tuned through the whole thing. That is not a small chunk of time, but hopefully some of you learned some stuff.
Oh, I'm quite sure. To be honest, myself, I did learn a lot. And even playing with my little gadget here at the same time. Yeah. And nobody died. The most important part. Yeah, and nobody died today, so it's a great day. This is good. So thank you very much, everyone. And then one thing here, yes, you should give your wife some time before she gets upset with you.
Yeah, we both should, Jeff.
All right, thank you very much, and have a good one.
All right, see you guys. And yeah Jake, I do CTF. We both do, actually. Jeff and I.
Yeah, we have a team. You should join the Discord server with us. Yeah. If you're not on Discord, join Discord, and I'll put it in a second after the stream. So stay tuned if you want to join Discord. On this, I wish you a good rest of the day, depending on where you are around the world, and then we'll see you very soon. All right, cheers.